Hi, Chris.
Hello, how are you?
Good. How you doing?
Good, good. I guess we're early. Well,
Yeah.
I'm early. I think you're here to
Yeah, I'm setting up the YouTube stream.
Hi, Chris.
yeah.
Yeah.
Oh yeah, there's the YouTube. Hello, how are you?
Good. How you doing?
Sorry, I
Good,
missed on
good.
that.
No, it's all good. I will I'll mute myself and let you go about what you need to do to set up.
All right, just give me a few minutes. I'll be back in a few minutes.
No, it's all good.
Hi everyone. Hey, how are you?
Good. I just finished setting up the stream for day 3. So
Awesome. Do you want me to check?
yes, please, if you can. Yeah. Can you? It should be on the website. Can you access
Okay.
it?
Yeah, absolutely. Absolutely. You read my face. I was like, what do I do? Let's do a workshop. Looks great, except for one of the moderators.
I'll make you a co-host. And awesome. How's your day been so far?
Long. I woke up like at 4 a.m. I kept thinking and thinking about the campaign events and things that did not kind of fit for some reason. And I have some interesting results to show.
I'm looking forward to that.
I am nervous because I'm really out of my comfort zone here. There are things that I need to explain that are like radiation belt type of things that I'm like not an expert whatsoever. So
No, I mean, I guess that should be fun. Phil is here. He probably knows a lot more about it. So he should
yeah. I always have hope that someone will know a little bit more and be able to.
And the really great part about this workshop, I at least personally, is nobody's like really judgy, or no, I'm not afraid to put something which I think is stupid.
Yeah.
So,
all your comments are brilliant. So what are you saying about a comment that is stupid? You ask the correct questions all the time.
No, thank you so much. But I on a different note, actually, I got the email from AGU Books. So
oh, yay!
I accepted it, and hopefully I'll be on time. Yeah.
If you need more time, just let me know, and I can deal with the editors, because I told them this is too close to AGU. People are going to need an extra time.
Right. Right. No, hopefully not. I'll let you know if I run into some obstacle or something.
Thank
And I will also drop you an email maybe over the weekend about the other thing we discussed. So
Sure.
I
Yeah.
never had the chance to, yeah.
It has been a crazy week.
Yeah. Yeah. And I have like homeworks due today. So I had like a crazy time with the office hours. So,
At what time do you have office hours today? Or
so my classes end at 12. So I start my office hours right after the class. So I have all the students. And this is the first homework after a midterm. So,
okay.
hey, Chris. Hi.
Hello.
I'm
So,
going to do an overview today. I'm going to show that I was wrong. Basically,
That I was wrong.
No, that I was wrong. You were right. And you will see that what you said yesterday kind of fits super nicely with what I'm going to show today.
Perfect.
So the timing is not an issue at all.
Yeah, okay.
But it's the fact that
You wasn't off by a ton, but it is embarrassing when you screw up the math.
you should have seen Carlos and I trying to figure out what was the UT in New Zealand. Both of us got it wrong. We sit down and it's like, no, it's this. No, it's this. And we had like half an hour getting the time correct. So
I found a website yesterday evening that does a local to UT conversion.
oh, I need that.
Oh, it's so helpful. You just tell it, well, you tell it which time zone you're in. The only problem, what could be a little bit better, but it would be ridiculous, is if you tell it your date and your location, and then it tells you what time zone you are in. Because like Alberta, right, you have to figure out between, am I in standard or daylight, right?
yeah.
And I mean, ever since the dates for the changed, I still don't know when the change is, right? I have to look it up and like, okay, I think I'm in daylight still, okay. And wait, when I took the picture, what was, you know,
oh my God, that's
the
crazy.
time zone change in 2017? I don't know. Oh,
that's really difficult. I was thinking it's complicated when you send an email and you say, let's meet at noon Eastern time. And I'm like, EDT or EST?
yep. Honestly, we should all just do everything in UTC and call it a day. There was a period of about 2 or 3 years where I had my camera set to UDT or UTC, cool. Sorry.
Yeah.
I had my camera set to UTC. I'm like, this is brilliant. This is going to save so much pain. And then Lightroom starts putting all my photos, splitting my photos up in the middle of the day because
you have
if I'm taking photos between let's say noon and midnight, right? Half those photos are on
the next day,
yesterday,
yeah.
And half of those photos are on tomorrow.
Yeah.
I don't know. What I want is just like a plugin probably for Lightroom, just to show me local time and UTC. And
what is very ignorant? What is Lightroom?
Oh, Lightroom's like for photographers. That's like basically our primary place for storing and editing photos.
Cool. Is it like, because like the only one that I have used to edit photos is Photoshop. That is one that I have here. Is it like similar to that?
Lightroom is made by Adobe, and it's basically Photoshop just for photos, right? So Photoshop is a graphic design platform,
yeah,
at its core, right? So Lightroom takes all the stuff that you use as a photographer out of Photoshop, and just that stuff, and puts it into a separate app.
Is it new or is it part of CS?
No, it's been
CS6?
around for quite a while.
I'm asking because I do have the CS6 and I'm not sure if I have it there.
It is, if you have the entire Creative Suite,
I do.
It's included. It's usually included with anything that has Photoshop.
I'll look for it. I can install it in the Mac, but I can install it in my PC one.
So like during yesterday, I had here. I'm going to show. Can you give me screen sharing for a quick second?
I think you should be able to do
Oh,
that.
I do have it. Cool. So this is Lightroom, and it's like I can quickly jump to photos from any year, any date. It's all it's all organized by date and year, and I can dive in and I can look at the photo, time it was taken, what were my camera settings at that time.
Are you familiar with, there is a software, a very tiny piece of software for PC at least, that is called Total Commander. Very, very old, where you can see all your files. It looks very similar to this one, but this is like photos.
This is, and this is just for photos. It's honestly, it's super useful. And it's pretty much for like Aurora photographers. I mean, virtually most heavy photographers, Lightroom is pretty much the gold standard. Apple had its own type of program that did the same thing, and that was a pretty solid competitor, but that dropped off the radar. Apple bowed out gracefully, I think around 2016 or 2017.
How do you remember what's the name of that one? I wonder if I ever saw it or
I think it was called Aperture.
Aperture? No, never used it.
It was not free and fairly consistent with Apple. It was quite expensive. Yeah, it was called Aperture.
All of these softwares are super expensive.
They are.
Yeah,
they are. Lightroom, again, if you've got Photoshop, Lightroom is usually pretty affordable.
Hi, Evgeny. How are you?
Very good. How are you?
Good. I like your picture. So beautiful. It's inspiring. Oh, yeah. We should have a Steve in the background.
Yeah. Kind of helps hide everything. Okay. So still.
Yeah, I know Carlos and Gareth are going to be a little bit late. Both of them commuting, so.
Technically, we're all commuting.
Yeah. But they're commuting physically.
Yeah, where are you now? In Nashville? Or?
Yeah. So I'm outside of Washington, D.C. right now.
Still teleworking or?
Still teleworking. Yeah, we're not allowed in center at all. Godar is working at 25% capacity, and every time I need to go there, I need to ask permission to everyone to just go and renew my badge and activate it.
Oh yeah.
So what about?
You know, Hazanov.
Yeah.
He complained that he had to be vaccinated, otherwise.
Yeah. What about you? Where are you right now?
Huh?
Where are you right now? Are you in?
I'm in my Albuquerque.
Okay. Can you go to work, or are you still?
Basically, we are. Yeah, we have, but I'm kind of free to choose.
That's good.
Whether from home. Not because I'm, just because my age.
You're very young.
Yeah. Well, I don't know. BU is still teleworking. Oh no, they have to.
I don't know. Toshi's not connected. Otherwise, I will ask him. I'm not sure if they're teleworking. I think Carlos has been on campus a couple of times. So I think they can go in, but it's not. It's optional. I think.
Probably Meir Scheppenheim told me that they should be at work. That's probably, I just recalled. What about you, Harat?
Oh, me? We are actually, most of the students are on campus. The classes are on campus. Actually, I think we have 60,000 or 70,000 odd students attending football games. But the good part is 95% of the student body is vaccinated, or at least that's what they're reporting. So it hasn't been too bad. Things have been under control. So
Yeah. No, our base, I mean, Kirtland, it's basically had only maybe 3 or 4 sick guys for the whole period.
okay.
Just given that it's about maybe 5,000 to 10,000.
Oh, yeah.
So lucky.
Yeah.
Hopefully next time we'll meet in person.
That would be great, actually.
Yeah.
Yep, I hope so too.
Good looking guys.
What's that?
A good looking guy.
Me? No. I'm talking about me. You must be talking about the antennas behind me. They do look good.
Yeah. I have a nice picture with John when I came in 1999. That's the
Yes, right.
breakdown of this raider.
I remember when you came. That was a nice visit. Evgeny showed up when we were still not in the wing that I'm standing in now, but we were in trailers down kind of closer to the antennas. 1970s era trailers. Fortunately, we got out of those. They were not doing well at the time.
I
What year
imagine
was
them
that?
warm and cold. Sorry, Bill.
It rained in Larissa's office frequently. Yeah, it actually rained. She was at the intersection of 2 trailers, and the problem was that there were 2 seams and they both leaked. And I used to have there was a woodchuck that lived under the floor in my office, and it would sometimes do this, and I'd have to, pound on the floor to get it to go away. That was about at the end of their life. And then we got money out of campus and built this nice wing that we're in now, so it's much nicer.
Yeah, that's good time.
How are we doing? So I guess Gareth was going to be a little bit late, I guess, right?
And Carlos too, I think.
Okay. Oh, right. Was that true? Okay.
He texted me saying that he was commuting and might be 10 minutes late.
Right. I think, Bea, you had a few things you were going to lead to begin with, right?
Yes, I am very excited about this.
We are too.
And I will need help, so.
Well, we'll do what we can. Do what we can.
Okay, I'm going to share.
Okay.
Should I start?
How are we doing? We have about 15 people here. I don't know how many were going to appear. Give it a minute. We give it a minute or so more just to see if we can collect 1 or 2 more people, and then we probably can.
You tell me.
Yeah, like here comes Naomi. I see. Watch for a couple more here. All right. And there's Jun.
Yay.
Yeah, that's good. He's good to have. Okay, so he's here. You could probably get started, I guess, Bea, and then we'll just let in people who come in the next little while. I'm sure they'll trickle, more will trickle in.
So, hi everyone, welcome to the third day. I asked the rest of the organizers if they will let me summarize some of the campaign results that we saw yesterday. The main reason I want to do this is because to me, this felt a little bit disjointed from my point of view. So this kept me thinking, and this morning I did a small analysis that I think puts things that we have been talking during these 2 past days together very nicely. One other motivation I had was what Josh Semeter said early during the week, where he said, I'm getting distracted. He said that we should look at this with very open-minded and not have a pre-idea of what is happening. And I think I resonate with that. And for those of you that do not know, Gareth, Bill, and we added Eric there, we wrote a paper about how Steve was discovered and what it meant for the early career scientists. And it's exactly that. It's facing a problem without having an idea of this is what's going on for sure. So to me, this is a continuation of that, of asking the questions freely. So in terms of the campaign events that we analyzed, to give you a very brief summary, and then I'm going to jump to several things that we have been seeing during this week. We look at 2 campaign events. The first one showed an intermittent Steve event that happened for 3 days. So this is the 2008 March from 26 to 28. And initially I marked that as a 3 interval event, but Toshi reminded us yesterday that it's actually a 4 interval event, because the March 28 event, there is a Steve happening at 2 UT, and then there is another Steve happening at 7 UT. So it's a 4 interval event. The second event, this was an event driven by citizen scientist data. And initially I have marked it only for 1 time interval. However, this event was also observed during 2 consecutive days. And when we started looking at the citizen scientist data, we realized that there were photographs from the September 2nd and September 3rd day. So with that in mind, and also thinking a little bit more of what we talked yesterday, so one of the main points that I took with me was that the Nishimura et al. 2020 paper suggests that there is a source of the injections that shifted rapidly towards the dusk sector. So this was potentially an indication that the reconnection region in the magnetotail has always also shifted towards dusk. The question here to me was, is this an indication that we might be having a very distorted magnetotail configuration? And I think the answer is we don't know, and we probably need MHD simulations to look at what's the magnetotail doing at this time. Also, what is important for this, Toshi analyzed this particular surge event, and it was 1 event, if I remember correctly. Toshi, correct me if it is more than 1, but Valerie Svaldi and Tomoko Matsuo look at the general convection pattern in a more statistical way, and their results actually support the Nishimura et al. Findings. So this is really important because it's not only 1 event, it's a pattern that we are seeing for all the events. So in that sense, then I started wondering, so since we see several days with intermittent Steve events, and this was corroborated yesterday by Mike Hanukel's list of citizen scientist events, where he said these occur, he has more of these events. These are no unique events in his data set. And I think the same is valid for my own data set. So then I think a valid question is, what is then constantly driving the magnetosphere to produce these type of things? So if I go back a little bit, and here I'm going to be completely out of my comfort zone and I might need some rescue, but I'm still going to jump. If I go back to the second campaign event yesterday, I told you that we had some Firebird 3 and 4 data. And Firebird, I told you, is 2 CubeSats that are studying the radiation belts. And for those of you that are not familiar with the radiation belt are a region of energetic charged particles that are very close to Earth, between 2 to 8 RE. So in miles, that would be 8 to 30,000 miles, 8,000 to 30,000 miles. please correct my math if that's not correct. And this region is really interesting because it's these very energetic charged particles that are usually in the shape of a donut. It's a donut shape or two donut shapes. So the typical observation is going to show you two radiation belts, an inner radiation belt and an outer radiation belt. And more recent results from the Van Allen probes have shown also a third radiation belt. But independent of that, this Firebird satellite is showing us the radiation belt data. And what we are seeing right now is the radial distance increasing upward. So we have 4 panels here. And what we have in the 4 panels, this is the 300 keV energy electrons. And this is in the first and third panel. The difference is this is northern hemisphere and this is southern hemisphere pass. And in the second panel, we have the more than 1 MeV electron. So this is higher energy levels for the northern hemisphere and the southern hemisphere. When people study storms, they usually look at these regions of dropouts. They call this decrease in the population in the radiation belt, the beginning of the storm. Here in this interval, this is not the Steve storm. The Steve storm happens here around, it's in September 1st, actually. That's what we were looking at yesterday. But what is interesting here is that we can compare this storm that I call the storm 0 with this storm 1. It's a little bit challenging for me to find the timing here for the Steve storm, but talking to people that know better than me, they said it's around this time. And when we look at the next slide that I'm going to show you, you're going to see the location a little bit better. So it's September 1st. For now, follow me on that. So what we see here that is really interesting when we look at the high energy particles, so the second and the fourth panel, is that for the first storm, we do not see any enhancement in the MeV type of electrons after the first storm. But when we look at the second storm later during the month, we do see an enhancement in the MeV population. So I asked my friend, of course, I want this to be geo-effective and can I call this an enhancement? And he told me, we need to look at ghost data. From this, I cannot tell you. So this morning, I make him look at ghost data. This is Firebird 4. And the story is similar for this one. So I'm going to skip it. So this is ghost data this is the first interval. This is the August 24 event. And what I want you to look at is the energy. Oh, my mouse is too sensitive. Is the enhancement in the more than 2 MeV electron that occur after the storm time. So this vertical dashed line is actually the storm time. And we see an enhancement in the very high energy electrons. And I asked him, is this consistent with what happened in the lower energy channels? And he said, usually when you have these high energy channels getting that enhancement, you also see it in the low energy channels. That's still TBD, but it's potentially there. When we look at the later storm, what we see is this is the time of the storm. We see an even higher enhancement in the more than 2 MeV particles. And that is exactly also what we were seeing in Firebird, where he called this a more geo-effective type of storm. And I think that's consistent with what we have been looking at the AL index, and here's the AE index, where we have, if you remember correctly, in the statistical study where we observe all these almost 30 events and look at the AL index, we found that the expansion phase for these Steve events was really pronounced when we compared with the regular substorms. The time of the expansion was double the time of the expansion phase for regular substorms. And to me, that was indicating that at that time, during that time interval is when you see most of the bursty bulk flows from the tail moving into the inner magnetosphere. So we know that the bursty bulk flows are an important source of energy for the magnetosphere. So the longer the expansion phase, the more energy you're dumping into the magnetosphere. To me, please, again, stop me or correct me if I'm saying something wrong. So that is completely consistent to what we were seeing for the AL index. So one thing that was curious to me, and that's the point that I wanted to make yesterday, independent of everything else that we are seeing here, is the timing. So one of my bias is I am coming from the substorm community. I am a more mesoscale type of person. So my time scales are usually of the order of hours. But when we look at these storm times, hours are not going to be representative for what we want to see. So what we need to look is days. And this is what I put here, that the appropriate analysis time scale are of the order of days. So having that in mind, and going back to the Gallardo-Lacour et al. Statistical analysis of these 28 events of Steve detected in Themis and Rego ASI, we look at the time intervals. What we have here is the DST index. So DST is in the y-axis as a function of time. 0, in this case, is the hour at which I detected the Steve event. And I plotted 12 hours before and 12 hours after the observation of Steve. And now we know that given the standard for the storm analysis, like for example, the plot provided by Victor Pinto et al., the time scale that the Gallardo-Lacour study selected is insufficient or even incorrect to assess if these events occur during storm time conditions. So I went ahead this morning and I said, 12 hours is not going to give us anything to know what is going on. So I decided to plot -3 days and +3 days. And this is the DST index that I obtained for the Steve event. Exactly. So what we have here again is the DST index as a function of hours, exactly the same plot, but it's longer. So this is 3 days before and 3 days after. And you can see that this is the mean. And even in the mean, it's really clear that we have a drop in DST index of about 25 to 30 nanotesla. And when I look at the individual events, we do have a storm type of conditions. So all the storms detected for these Steve events show a moderate DST decrease. And this is absolutely consistent with the optical database that we are using, because moderate DSTs are going to push the equator boundary of the auroral oval closer to the southward portion of the camera's array. And if we have more disturbed conditions, then the subauroral region is going to extend further equatorward and it's going to be outside of the camera field of view. So that's why these moderate DSTs are showing Steve at that location. So the question is, can we still observe Steve during more disturbed geomagnetic conditions? And we all know the answer, absolutely. And this is because Ian Griffin and Carlos Martinez at the beginning of the week, or at the beginning of the workshop, I should say, show us Steve occurring during the St. Patrick's Storm event on 2015. And where did it happen? Very equatorward in Dunedin, New Zealand. And that's the last thing I have.
Okay.
Has it?
Oh, sorry, Evgeny, go ahead.
Okay, sorry. Very slow. Basically, you know, there is a very nice statistical data set for SAD. I mean, in terms of dependence, you know, where you observe it during between kind of L shells or latitudes, depending on the magnetic activity. So basically, it's I mean,
yeah,
it's very much the same as you know, the Steve statistics.
And it is very consistent too, because if we think about SAR arcs are usually associated with storm times. And the fact that we are seeing some Steve events together with SAR arcs were absolutely telling us something.
Right, and I can tell you that when you look at Millstone Hill, when it looked for SAPs, not SCIDs, but SAPs, and we sorted it by DST rather than just, we found exactly the same thing, is that everything pushes equatorward. So you could just have an observational bias here with the Themis and Rego, but as you said, that emphasizes that the citizen science observations might help you fill in some of that gap, right?
Absolutely, absolutely. If we use the citizen scientist data, we'll probably move from this very moderate DST that I'm showing you here to something that is potentially more strong.
Right, right.
So I think there's a really interesting implication to Evgeny's comment about effectively, if we find a property that we associate with Steve and he says, well, yeah, we already, we already know that about subaraural ion drifts.
Yeah.
And that's the question. So every time anybody brings anything up about Steve, I ask that same question, because I think we should be able to, if you bring anything to the table, I think we should be able to ask, do we already know this about subaraural ion drifts in general? And if we don't, we should ask that question, because it's probably a relevant and interesting thing for us to know about subaraural ion drifts in general. And if we ever find that that's not the case, well, that's even more interesting. If this asymmetry, that, Toshi and many other people have been talking about associated with Steve, is this, if that is unique to Steve and not to strong subaraural ion drifts in general, well, I would love to know that.
Absolutely agree. And I think exactly in the line of that comment is why, to me, yesterday, the discussion on my side felt very disjointed, because I could see the magnetotail needing to be something stronger. It has a stronger driver than just having substorm. The substorms are there. I'm not saying the substorms are not there, but these are different substorms for every different Steve. While for the storm, it's one storm probably for an interval of Steves. So those are the things that in my mind were not very well pieced together, and is consistent with what Evgeny is saying. These are things that we know in the subaraural region. So now to me, it's like a little bit more cohesive story.
Right. And again, very, very consistent with where the dusk sector stuff is closing. It really is.
Sorry, I just keeping forgetting about it. Basically, that's relevance to storm or relation to storms. If you recall, Tsyganenko model, Tsyganenko 2003, I think, when he first showed that during storms, basically, I forgot how it's called, but basically the magnetosphere, in the magnetosphere is kind of skewed, so that standard MLT, especially on the dusk side, should be changed by a couple of hours or so during storms. So that's consistent with this, dusk side shift positive.
Excellent.
I agree.
So the moderator, my hand has been raised for like 15 minutes.
Sorry, who's the moderator?
By the way, Toshi just appeared too, so we ought to get his comments after Carlos goes, because his hand's about to fall off.
Yeah. So I think I missed most of the talk, but I saw this last one. So basically, the conclusion is that your observations or your statistic is more or less biased because you are looking over a region that doesn't need strong storms. Okay. No,
I'm saying that the Gallardo-Lacour et al. 2018 statistical study, it has incorrect or insufficient time scales to analyze whether or not we were looking at a storm. And when I change from going from hours to days, that is more consistent with what is happening with the storm, then you do see the decrease in the DST. And it's a moderate DST because of the limitation of the array.
The field of view of where you are.
Yes.
Now, perfect. And the second point is, and I think this could be very important, is the fact that line 0 is not going straight through the negative phase. It's happening after some kind of recovery.
So be careful here. On one hand, I do feel like we need to look one by one and not only at this kind of very mean type of thing, but also this time 0, since I only had like a couple of hours to do this.
Oh, okay.
The time 0 is just the beginning of the day. when Steve is observed. So that's a 0 hour of the day.
Not the time of the Steve
Not the
observation.
exact hour, no, not yet.
Okay.
But
And another suggestion,
but
the
it's going
last
to
one
be
is
here.
perhaps, okay, okay. So sim age also could give you some more time resolution. I don't know if that would be relevant, but.
So that's something I'm pushing Victor to do, because he's looking at all the list of Steve events right now, and he's going to make this type of plots for all of the events.
Just a comment to this. I have all the DST values for the citizen science observations of Steve in my list, and did some analysis, also the DSTP values for the related geostorms, phases of the geostorms for 150 days.
Michael, why don't you have? So you have everything.
I was going to propose you, maybe we can write something together.
Yeah.
I just put some comments in the chat, and also a list with citizen science observations for the same day from both hemispheres. I have 16 days with different time delays. But a time delay mean time delays for the reporting time. That does not, of course, mean the exact time for the delay of the Steves. But I think that could be a starting point to get in contact with observers to have a look at what time range they have recorded. So in general, observers only posted a few images. If you are lucky with time, if you ask, you might get times, but in most cases, the observers took a lot of photos over if they can, the whole time when Steve was visible. So
at this point, I would be even interested in something very general, that it's an approximate time, and we still see an increase in the DST index because you guys have a better coverage. Yeah. Since you can, the citizen scientists can move around and fix by the location of the instrument. And
another comment. Yesterday I put a link in the chat to a list which already contains a summary of the correlation between Steve observations and geostorms with the DST index values. And if you have a look in this list, you can directly see events where Steve was reported on several times in a row. So yeah, I think that could be a starting point for a deeper analysis.
I also want to add that for plotting here, so events like the first campaign event that we analyzed, where we see 4 observations of Steve, was considered as 1, just in case.
Interesting. You can, of course, well, Van Allen Prose was up in 2016 as well, so you can certainly go there. By the way, just to remind people that 300 keV population that you talked about there, in addition to the relativistic stuff, which is more than 1 MeV, Allison Janes has shown that, that is a seed population. And it's kind of like you have to have all the pieces together, and you need the seed population to, for example, generate chorus waves out in the magnetosphere that start scrubbing the relativistic particles out and then accelerate them again. And it probably happens a lot faster than the community had been thinking about before with quasi-linear diffusion and what have you. But that pairing is very familiar to people who have been looking at a lot of Van Allen probes data. And I'm just not used to looking at it in LEO, but I think if you check the Van Allen probes, you will find that there's also a bunch of chorus and enhanced chorus and other wave activity out there that's actually driving that. But your point here is good, is that it's got to be G-effective. It's got to make it down to here as opposed to being just out in the radiation belt itself. So this is the way to check it.
And we briefly look at other events. Victor did an entire study with GOES and RBSP, and this morning we just checked with GOES.
Right.
But I will say what you are seeing in this event is representative of what we saw for the other ones.
It'll hold up. I don't see that it's going to, the particle data is really going to change that much.
Let me squeeze in with a comment. Basically, back 10 years ago, we published a paper connecting VLF visitor waves inside the plasma sphere, actually inside the SID, right?
Mhm.
And found that the diffusion rate due to this visitor, you remember, maybe you remember this bump near the plasma pulse, bump of spike of waves activity. And significant part of these waves, electromagnetic His-like visitor emission.
Mhm.
And so when you calculate diffusion rate or a lifetime of relativistic electrons due to this wave activity, you'll find that it's very nicely match the relation which found by Lee and then Jerry Goldstein of the relation of the boundary of the outer radiation belt and the plasma pulse. So I mean, we did not, fit, or we just put whatever we observed into the more J. Albert model, and got this result. The main point is that when you look at the electrons, seed electrons, keV or 10 keV electrons, which are needed to be accelerated then, to MeV, you'll find that inside the plasma sphere is devoid on the dusk side of such electrons, because because they are, this mesoscale or Birch-Debye flows stopped at the plasma pulse, I mean the electron population, so they don't penetrate inside. However, the visitors are there, which are needed to.
Yep.
And basically the mechanism for this visitor generation is coupling of electrostatic waves. So that helps to avoid the standard mechanism of generation.
Yeah.
So that's consistent.
Yep. That all sounds very familiar, Evgeny, and very plausible. I think that's that all of those are involved. So Bea, this is just to say that, yeah, this needs to be followed up on, but there's nothing in here that makes anybody so far, throw up their hands.
And then I'll need help with understanding the radiation belt. So I'll probably contact you, Evgeny, because I'm not that familiar with that type of study. So
yeah,
I'd be very thankful if we could chat. And the same for Toshi, but I know he probably has good ideas too.
Sure.
Mm-hmm.
Sorry, I just missed the earlier portion of this meeting, but yeah, I saw you were showing, the preference of weak storm for Steve.
Yeah. So if you remember in the study that we did in 2018, we look at the DST index, but since I said I'm a substorm person, I look at the order of hours, and that's insufficient to look at storms. So this morning I decided to extend it to ±3 days. Sorry. And when I did that is this plot, then it's not a flat -20 nanotesla DST. And it's a moderate storm because we are constrained by the field of view of Themis and Rego.
Yeah, that's probably the case. One of the Steve events I have seen, that's a May 8, 2016 event. That's a DST -100 now Tesla event. So that was detected in the state of Washington. So yeah, so for larger storms, Canadians can't see Steve, but people in the US should be able to. I guess the question is why there weren't any, at least known or popular reports from people in the lower states about Steve, even though bigger storms have happened before. Are there anything special for weak to moderate storms, or people at lower latitude just didn't care too much for
You are closer to big cities, I think.
That's what I was
That's
thinking,
another-
light contamination.
Well,
Right.
so the Steve event I just mentioned was taken out in a suburb of Seattle. So there have been, good horror reports in that area, but Steve events have been pretty rare.
Yeah, but still, these are speculations. We just need to check, right?
Yeah, sure. I guess my basic question is if Steve could have happened over Milton Hill, for example, why we didn't notice earlier? Although there are many SARC reports.
Yeah, Carlos, we would have been able to see it given the background light here. We should have been able to, right?
Yes. One of the things that the tasks that we need to do here at BU is we have a spectrometer that's been operating for years. And I think we have not done a careful job looking at those cases in which we observe SAR arcs as we define, and simultaneously with spectrometer, or other nights where there were storms, no SAR arcs, but perhaps the spectrometer might have detected some kind of enhanced emission on particular lines. So that could be something. But definitely, I think if a Steve was occurring, we should have observed it and appear. Yes.
I'd just like to interrupt it. Liz McDonald would have, I think she has something to say about this. Her hand's up, and I think she may have some key insight about distribution of observations across North America. So, Liz.
Yeah, thanks. I just joined, so I'm not sure of the whole context of your conversation, but I would just speak a little bit to, the weather is always a factor for a given storm as well. And we also haven't had that many large storms in the last few years for sure. So those two caveats aside, Michael's database really does show a lot of observations. It can easily be searched for larger storms and observations from the mainland US as well as other lower latitude locations. So I think Steve's been seen as far south as, maybe Wyoming in some cases, but it always just depends on the weather for a given event. The most recent event, the Canadian Thanksgiving storm, was definitely seen over Washington because Washington was clear as well. So, and North Dakota.
There are also some observations of Steve from Victoria in Australia, not directly at the coast, but from the mainland. So there's also quite low latitude.
Yeah, following up the comment from Liz, I've been in Boston for 20 years, more or less, and I think there were only 3 or 4 cases in which KP was large enough to have aurora over Boston, but guess what? It was cloudy.
Yep, agree.
So,
I've been there.
And the weather thing, what Liz was saying, I mean, I always remember Eric saying one of the major things they found out about, the Themis all sky imagers is that the moon is very bright and it's always cloudy somewhere in Canada. So, the fact that, the weather would probably have a very big factor in the observations.
I also have a comment with the timing that I think we might need to consider, and this is just an idea out of looking at just a St. Patrick event. To me, this event for Steve is not very long lasting. And I wonder if, depending on where you are in the storm time, the duration of Steve might change. So you all remember that we saw this event from Ian Griffin. This is the 2015 St. Patrick Day storm. And Carlos and Ian were highlighting that you have a SAR arc initially, and then you start seeing the formation of Steve first in the east, and then you're going to see it propagating from the east all the way to the west, while the red arc gets a little bit fainter. Unfortunately, it's slightly cloudy, but now you can see the Steve formation. And then a little bit later, you're going to see the green picket fence that are right there. But if the evolution is really fast, Carlos, if I remember correctly, this is less than an hour.
Yes, this is the overall evolution. And I want to make a point. So observations start at 9:22 UT, and the arcs are gone by 10:10 UT, less than an hour. one point that has not been mentioned, and I think this is important related to the satellite observations, is that the first images, I think, are already showing some kind of transition, because if you check the thickness of the arc, is not uniform. The eastern part is thinner than the western part. The eastern part is the one that the satellite is crossing, is when we see this kind of embedded SAIDs inside the SAPs. So I think the transition is already occurring, and the arc is thinning in the first part, then thins completely and then change color. So very interesting event.
Definitely a lot to do.
Several avenues there. Yep.
Yeah.
Okay.
So that was all what I wanted to show. Thank you for giving me the time.
Nice.
Good.
May have some words. Actually,
Sure.
when you look at the DMSP data related to subaraural events, you'll find that there is a contamination, right? And this contamination is due to precipitation of MEV particles. So that's basically huge
Sure.
statistical set, you know. You don't know, there is no doubt that, you know, during SAPS or SAD events, you have very strong MEV precipitation inside the plasma process.
Mm-hmm.
And that is important because, so talking to my friend that is more radiation belt, I could never get him excited about Steve. And I kept telling him, but it's about the same region. We are in the transition region going from the stretched tail to the more dipolar field. So it's closer to the radiation belt that I have ever worked. And that's something that we need to have in mind, that this is, to me, Steve is an excellent example of magnetotail, inner magnetosphere, and ionosphere interactions.
Oh, yes, of course, yeah. And basically, when you look at any data, I mean, even old CREST data, then you see a lot of VLF activity right during this subaraural event, subaraural intrusion, I mean, recurrent injection, if you want. So that's,
Right. Other comments on all of this? Great. Okay, where are we? Are we shifting into the attempts to do some summary? Is that where we are?
Yes.
Okay. So here's what I would propose is I'm going to pop something up on the screen, which is essentially hold on a second. Try to do that. This is essentially a set of notes that we've been taking, but I'm just going to have the blank part, and I would ask my fellow moderators here to look over the notes that we've been making, and I'd like us kind of collectively to try to figure out if we can pull some of the threads together here about key items we've talked about in the last couple of days, because our goal here for the rest of this block was to try to do some specific thinking about kind of actions that we saw that we could take and get ourselves a little bit organized. So this lovely blank page is where I'm going to be. And so since I'm not going to scroll back and forth looking at the notes there, does one of the, Gareth or Bea or somebody, do you guys want to take a crack at starting here?
Sure, I think I'm muted, but absolutely.
I guess I'm just, yeah, I'm skimming through the talk. I mean, one of the things should we just go right through in order? I guess is it the best, probably the most efficient way?
I think whatever works, and then we can reorder this later. I think so. Sure, but we can measure things, and then we could get some triggering of people's comments on whether they too found that that was a sort of a obvious thread. So yeah.
Well, okay. I think one of the obvious threads in terms of actions and low-hanging fruit, it came up in Evgeny's talk. It came up just 10 minutes ago. I think is just a need more examination in terms of the initial conditions of the system. And as Bea was just quite nicely illustrating that, we need to look beyond 12 hours ahead.
And I also think so when we plan the workshop, we try to bring everyone, and I think we're still missing MHD modelers to look at this problem. So we're missing, yes.
Well, because we've clearly heard that there's a magnetospheric configuration effect, and yeah, to examine, right. Right. Okay.
There is an absolute need of a repository for the citizen scientist data.
Right. Hold on a second. I'm going to just move that back here. Yep. And, it doesn't have to be created out of nothing. Obviously, Michael has done a staggering amount of work. We just need to figure out, I would think, a couple of things about that, like, how to access, what metadata does the community need? Sub-bullets like
any of the citizen scientists can say,
yeah,
would like to say something. Emma, or
right.
Chris?
Are you? I can't see people.
No, just unmuting. Yeah, I think if we could get access to being able to see Steve events in relation to the space weather data at the time of the event. So those conversations around DST and what was happening at the time, quick and easy access to that would be really helpful to be able to see what we might want to look for as an event is firing up. That would be helpful. I mean, Michael has some of that already available. Clearly, he's got this entire database, but being able to cross-reference that would be really helpful.
Okay.
We do that sometimes, right? Like I've done that and gone back into the data, but having that fine-grained data is not readily available to us.
All right.
Out of curiosity, on the topic of metadata, from my perspective, I'm always of the mind that lat lon time in UT is sort of like everything else can be done by the user. Am I missing something?
Well, which latitude and which longitude?
The location of the person where they're standing.
Okay, you're talking about geodetic.
Geographic.
Yeah.
Yes.
Because I feel like trying to predict what everybody's going to need seems dangerous, but if you don't have the location of the from the photographer in 4-dimensional space and time, it's hard to do. It really limits what you can do with it.
Okay. Gotcha.
Kind of related, especially around precise time. A really reliable local to UTC converter calculator would be spectacular. That is such a pain in the butt trying to convert my time in, especially looking back. So this was my experience yesterday. Looking back at an event 5-6 years ago and trying to convert that time to UTC was challenging because I'm trying to remember, when did we change clocks? When did we change when we changed clocks? All that stuff started bubbling in my head. It wasn't
Yeah.
fun.
My list also contains data for transferring the times and also the dates when the clocks were changed.
Of
Right.
course you
So,
did.
Michael,
So we
the
just-
thing is, in
Yeah,
this
so
list,
ask-
you've done a lot of this already. And that's the nice thing. It's just that but it's nice to lay it out so that we sort of know. I mean, believe me, and under any circumstance, I would start with what you have, very frankly, and I would just see what else we'd need to, if there's anything else we're missing. But it's nice to have it laid out here so that let's keep going here. Are there other things here that this? So for science analysis, is there extra stuff here that we need to? That's just again drop dead obvious. Michael, what else is in your database here that I don't have on this list?
Ooh, what do we have? I have an analysis for a correlation of Steve observations reported with time with phases of geostorms. I did that just out of curiosity because it might come out that it is worse to have this data if you look on Steve on a more global viewpoint. And yeah, this is
okay. So it's really it's storm phase interval information, right? Yeah. Okay, that's important.
But what I not did is an analysis with the a complete analysis with, for example, GP index or also the AE index. I have all the KP data in my list, but I think that KP is not a good measure for Steve. There's no clear correlation between Steve and KP index. But for other indexes, I did not have time to do that. I think it's very interesting, but yeah, I need more time.
Sure, of course, but gotcha.
Michael, I mean, from a regional observation perspective, I find KP to be useful. I'm less likely to see to see KP. To see Steve when KP is 5 or 6 a lot of times, because if the aurora is overhead, then Steve is out of my line of sight.
Mm-hmm. Yeah.
But that's just from a location perspective.
Yeah.
So.
Yeah. What I also did is I made some statistical analysis in which months Steve was reported most. Compare that with the statistics of geostorms. I did that for different regions. For example, for North America, separately for Europe, separately for the Southern Hemisphere. Yeah. Compare reporting rates for different regions, and it comes out that the rate for the northern part of Germany is, northern part of Europe is significantly lower compared with Canada, for example. Even if you go to similar geomagnetic latitudes, and I think it could be worse to have a closer look. What is the reason for that? Is this just, for example, weather biased, or other observers not reporting as often as from Canada? But yeah, I think for the last years, this is not the reason, because in Finland or in the northern part of Great Britain, I think the observers caught a lot of Steves, and they are out every night. The weather conditions are fine. So yeah.
Sure. I mean, those are derived products to me from like the metadata of where they were located. You've then done the analysis that sits on top of that, right? And looks for correlations and develops patterns.
This statistics is related to something we were discussing yesterday, I think, when I asked. So if you go outside and you see nothing, there is no information that on this night there was nothing. And that's crucial to get the proper statistics. The fact that you see something, it could be you and Dorothy. Yeah.
So way to determine nothing was seen, right?
You can't get proper statistics from citizen science data. Generally, it's not an appropriate question for that type of data fully.
The nothing was seen kind of thing.
Important, but the absolute statistics rate, that's not the way to do it with these kinds of data, because you're always going to have geographic bias.
That's okay, right? If you looked at the way this data was clumped.
Yeah, but you can.
I also remember I also remember someone mentioning, Liz, that it was really difficult to get those negative reports in Aurorasaurus. Is that true?
Negative reports are broadly difficult to get throughout citizen science. Yeah. So yeah.
I mean, Liz has even specifically asked me to send in negative reports, and I'm horrible at it.
Okay.
You should lead by example. Yeah.
Very hard.
Another list that we don't have so much, and Michael and I have been talking about this for years. We have a ton of metadata. He has a ton of lists. It's generally appropriate enough that he just got real funding for it. So, you know, it's probably not our most like you all should look at it and then make suggestions for other ways to parse it, and or what science questions are the low-hanging fruit. One that occurs to me is that we don't have quite as much of lists of scientifically, for instance, the SAR arcs. I know there are some lists, but if that's available as well for cross-checking, that seems like as well.
Okay, that's outside of the citizen science database then, Liz. It's just a separate indication from somewhere else that says.
From other observatories as well. So yeah.
Yes, right.
I got that list from Carlos, and it was really hard to get him very short.
Yeah.
Right.
And I know it exists, and I know you have it, Carlos. I just think putting them together in the same place is what I'm.
Absolutely, yeah. Yeah.
Well, it
will not be as populated as the Steve database, but yeah.
Same way for the local time to UTC. I mean, yes, you can do that anywhere, but just having it right here would be useful. Sure.
One thing I forgot to mention is that I already worked on a list summarizing other subaurora events which cannot be clearly classified as I call it classical SIR arc, so long living, extended, faint red structure, or Steve. And in some cases, there looks like, just based on images, as some kind of transition, or there was, in some cases, an extended greenish diffuse arc as a position where Steve was. So I have also a list for such observations. It is on my AGU poster that I had last year, and this poster is still online. So if someone like to look at such events, I also have a small list for that.
This is probably a better question for the next session, but I'm going to ask anyways. When you say a green arc at the location of Steve, is it Steve or is it a star arc? And I'm wondering that because I know Carlos and Mike Mendilo have papers where they have show star arcs with other type of emissions, right, Carlos?
Yes, but I think what he's referring is a particular kind of observation that Emma, I think, also reporting, which there is a green structure,
like
very
a blob?
close to, not really. No, there are blobs too. Yes, and there is arcs that's next to a red arc, separate.
And there are also Steves with a greenish lower border, diffuse. Also on images with a short exposure time. So there might be cases where Steves really have a lower green edge.
Well, wait a minute. In our metadata, what about the image itself? Do we need to add that isn't embedded in like the EXIF or something like that of the image? Because I know you can get basic parameters like exposure time and what have you off the things that the camera is tagging, but what has to be added to the image itself that's not here, other than the other information we've got listed that allows you to then start registering it? Is there anything else that the cameras you find don't do that you have to mark? I'm assuming the lenses and what have you are transmitted, right? Hopefully, and they get embedded in the EXIFs for these images, or is that not even the case?
But with some of the manual lenses, that information does not get recorded. Some of us might be using manual lenses that don't have an electrical connection to the camera. So the F ratio wouldn't be recorded, but the shutter speed and the ISO inherent from
Sure.
the camera, that gets recorded in the metadata as well. And also, but what might not get recorded in a sequence is the cadence if we're taking or submitting a whole series of shots, perhaps. How often were those taken as well, to show how long did it take for that formation to develop and change. So that information would have to be supplied.
This is sort of a cadence. Okay, go ahead, Liz.
Just that Michael's original list is scraped off a lot of different places. And so people post their photos in different ways.
Yeah.
And part of the actual work of, I think what can be useful, what we're pointing to here is that data cleaning is important. And I know Michael already has some quality tags in some aspects of his list and his metadata, but quality tags for this is absolutely a raw image, and we have the information out there. We have the camera information that could be a qualifying factor for like level 2 citizen science data here or something like that. But you know, it's mostly just a question of the data cleaning, and the original list is a little bit messier in that way, and they both have different purposes. Depends on what you want to do with it and what the science questions are.
Right. Yeah. So there's not one list of tags you're saying that you always try to make every image come up to. I take it, right? Because it depends on the application.
Yeah.
Something like that. Okay.
How about regular weather in addition to space weather? I mean, for citizen science observations, like I wouldn't expect people to go out when it's snowing or raining or when temperatures really low. Maybe just
yeah, that's a good point, Brett. Lindsay has a comment on the chat there related to that. Actually, I'm just seeing it now.
Okay, can you read? I can't see the chat right now.
Oh, it said almost what Brad's saying. She says just putting out a weird thought related to the discussion of data repository is a desire to incorporate street and weather cameras into our data sets. For example, I am creeping on Alaska street cameras, and maybe even simple cameras like this could help determine when Steves are.
Oh, you're talking about as it not as extra information, but as a primary source.
Yeah, I thought I started reading. I thought she was talking about weather conditions, maybe explaining failed observations, but
I can sort of speak to both of those just a bit. We've always wanted to incorporate, you know, the cameras in different streams, but have never really had time for doing that. I think that is kind of next generation scraping video data or webcam type data as well. But just to speak to Bharat's question of cloudiness and weather, the actual Aurorasaurus protocol, if you look at your reporting, no, I did not see aurora, there's a form. And so we distinguish between whether the sky was clear and you didn't see aurora or there were some other factors. So you have to look at that. And again, that's nothing you can get from scraping per se.
That's right.
An automated way.
Yeah, either the user reports that if you're lucky, I guess, or you don't get that. And then you'd have to go somehow figure it out from some other piece of data that you'd have to add. Liz, is this another variable that again depends on the analysis target, or is that so fundamental that, you know, it's always useful to have? I'm just trying to put it on the scale.
Yeah, no, I can quickly speak to how we use it for Aurorasaurus. So for Aurorasaurus, like negative reports where it's cloudy are useful in real time for people to be able to see that it's cloudy somewhere else. But they're not useful for the downstream, any kind of absolute rate or comparison with an auroral oval boundary, model boundary, for instance. So when we clean our data, and again, Burju Koshar did a paper on this, the clean data, the set of no's is clear sky only, I believe, but it's specified in that paper.
Okay, I see.
I feel like
so that
boundaries are tricky. You're talking about like overall boundaries?
Yeah, we have several papers where we've compared points of data to where the model boundary are. That's a whole
boundaries
separate
are always tricky because the best thing that you can have the boundary from is the MSP satellite, and that is usually going to give you a point measurement. What we're doing right now, actually, with Larry Kepko is looking at DMSP passes and redline imagers and how at least with the power boundary right now, how the power boundary correlates statistically with that power boundary observed by DMSP. And we're planning to do that for the equator boundary as well. Once that is there, I feel like we could have a better marker for where the boundaries are, and that would be completely useful for what you are planning, I think.
Yeah, it's also, Ovation Prime has a view line, and some of our first work with the Aurora source data demonstrated that citizen scientists can actually beat that view line prediction. It's an extremely rough prediction, but those models and those comparisons. So I think we're saying the same thing as well.
Yeah,
we're on our own little tangent here. Everybody else wants to go off back to Steve, but it's all good.
Okay. All right. The only reason I was mentioning, some of these are going to need more thought, obviously, because there's always a cost versus a benefit for adding each of these metadata tags. Look at all the work Michael's had to do, right? It's like, you don't want to push a boulder up a hill if, as Liz says, you don't have that many applications for the metadata, even though it would, quote, be nice to have. So this ties back, I guess, also to what you've mentioned a couple of times, which is what science questions are you going for now? And what questions could you reasonably, that'll help you, I think, rate the effort for these metadata tags.
I also think it's very worthwhile to track a lot of these things that are listed. If I have the time, I can look up all of those things.
Yeah.
The ones that I've lost, if once you've, can't speak to the photographer anymore, so whether it was cloudy that day or what, I don't know, other pieces of information that might be lost when you don't have the actual observer, those seem very high value by contrast.
Yeah. So it's like metadata that depend on a direct observer contact, right? Where you've got to talk to the person maybe to really solidify something. Might be prioritized, right? That kind of thing. Yeah. Okay. Well, that's a lot of items for this particular area. Should we try to find another bullet here? I'm sure this is.
This is something we talked among the organizers that we needed to bring to this. So we're talking about repository. We're talking about adding the citizen scientists to our meetings, and that requires money and resources. And we talk about, we are the ones that know how to, or the more senior, especially not me, that know how to write very successful proposals. So we are the ones that need to look for funding to support the citizen scientists.
Yeah. Scaling the proposals to be right sized to, you want to be able to, and also you want to say fitting efforts into a longer term plan, right? When you get something going beyond a certain point, then it's got a momentum, and then you want to keep it going, and grants don't last forever. And so then you have to think about what's coming next, right? So those sorts of thoughts in here. But yeah, I agree with you. Those are other items in this area that people who do this stuff want to add.
It might be a good idea to ask the folks who are on the line from the citizen science side what support would be most helpful to you. Right.
So let's add to that right now. So what would you find useful?
Not to put you on the spot, because that's an awkward question. It's all an awkward question. It's not an easy thing to do. Right. We can't promise a lot of things. But yeah, just in terms of, time to attend a meeting or funding to attend a meeting, or yes, I really do want to do a whole lot more of this analysis type of work, or no, I don't really want to do a whole much more of this analysis work. I want to take pictures.
Yeah.
A, B, C, D, or something totally different. So just want to pause and see if anybody wants to say anything from that perspective.
Mm-hmm. What jumps out of your head, really, just in terms of usefulness?
Well, if I've got pictures that any of the researchers need, then I don't need any funding or any incentive to submit those. I will submit whatever I can. So I can't think of where I would need funding in that regard. But just in talking to, just in chatting with Jeremy in the last few hours about his planned prototype of the all-sky camera that would be very portable. If at that kind of system could get implemented and produced, that would and put into the hands of a number of us citizen scientists, that's obviously something that needs to get funded in some way, and that could produce more valuable data useful to the researchers if it's a common system that we've all agreed upon is going to produce useful data and put it into the hands of us around the world. And so I'd be happy to take a system like that, but if it's going to cost $2,000 or $3,000 or whatever it is, that's something that has to be funded and put into the hands of the citizen scientists.
That's an excellent point, Alan. Actually, I remember when we met with you guys a couple of months ago, we were wondering about and this is a question for the University of Calgary folks. I know there was an initiative to try to build a portable and kind of low cost spectrograph. Did you guys pursue that idea?
Anybody on the line?
Yeah.
Oh, yeah, I'm here. I believe Chris Cully was actually doing something like that as well. And I thought he had actually made a low-cost spectrograph that was sent out. But I don't actually know where that ended up or how it was used.
I've also developed a mobile spectrometer. The first prototype is ready. So hopefully first test can start soon. So
Emma, you had something, right?
Yeah, I'm laughing at myself.
But there's one point that I cannot do with the spectrometer, and this is and perhaps you can help me with that. Is the just a minute. The spectral responsivity is not calibrated. So what is very easy is the calibration of the wavelength. That's a quite easy task, and the spectrometer is also extremely cheap. I think material cost in the range of less than $100. It's more or less completely 3D printed in my own very little workshop at home. And also the optics are very, very cheap in that. But with the tools I have at hand, it's not possible to do a calibration for the spectral responsivity, and I think it would be necessary to have such a calibration to use it properly, because you don't want only to know what wavelengths do you see, or if there's a continuum, you want to get knowledge about intensity ratios.
Okay, but it's generally help with calibration and instrument characterization, I guess, is the more general. I should put that down. Yeah, that's better. Okay, these are great suggestions. Keep them coming. Anything else? I like these bullets very much.
I think one point which is also important is that we should think about some kind of definitions, what terms citizen scientists can use to report on observations, because most citizen scientists use, how can I call it, a different kind of language to explain things compared with scientists, and this can be a point where they do not understand each other's. And then if there would be a list with terms they used to report on specific events, that could help to identify these events faster and forward them to scientists.
That almost speaks to it came up last night, the rural tree or tree of rural forms or something like that. If the family tree or something, I can't quite remember that. I'll have to look back on the notes. Emma, did you have something you wanted to add?
Well, a couple of things to several points mentioned. Of course, the spectrograph thing is interesting. I've got a ridiculous kind of spectrograph kind of in production, and it needs to be calibrated, but it's currently still sitting inside a toilet paper roll, which isn't a stable mounting for anything useful. So that needs to be still improved. But personally, I'd love to try some kind of machine learning algorithms to images, either from all sky cameras or from private observers. So this is a thing that's in my list of things to do before you die. And I don't know if that's going to happen, but one thing to see, look at this, what could be useful for citizen science participation is the other question, other way around. What is it that you most need for your research? Because if you need more observations, this is something that could be improved. It requires something and can be kind of analyzed by asking more questions like, where do you need more observations and what kind of observations? And then we get closer to the parts which need more funding or support.
Hang on, I'm reorganizing for just a moment because these are more general. These aren't just necessarily funding. These are things that need to be done.
Yeah, one of the things we were discussing, and I think is we depend 100% from you guys, is the observation of picket fences, the kind of resolution and the speed that we observe them. So ideally, it would be, let's say, a situation in which you can see the picket fences from 2 or 3 different points of view, vintage points of view, that will help to, for example, determine height and other characteristics. And I know that this is not something that you can plan. Say, okay, you are in this location, you in this other location, and coordinate when there's something that, let's be sure that the 3 of us are taking data. And so that's the kind of information that might help us directly.
I also want to, sorry, Emma, go.
I was thinking that the probability of seeing something like a picket fence depends on different factors like what data sets are available and how many observers can we get out. And that would mean that we'd need to improve things like how to know when to go out and how to get more observers to the network.
I also wanted to mention that in the conversation that we had with the Alberta Aurora Chasers, and this is super important for modeling and for understanding the physics that is behind, we had a conversation about, since our scientific instruments have more limited spatial resolution, we totally rely on the citizen scientist data. So one of the questions we asked them is about the timing of the picket fence. Do you guys see it before? Do you guys see it during? Do you guys see it at the end of Steve? Does it occur usually on the northern edge or in the equator edge of Steve? And if I remember correctly, you guys told us all of the above. And I think information like that is extremely important if we are going to try to model these things.
Just to add on to the laundry list as well, that's excellent. Going back to what Carlos said, I do actually think that ad hoc networks of people are already occurring, and we have a lot of excellent examples that could be triangulated. And Michael's done a lot of work on this. What we don't have are off-the-shelf tools, software tools that people can use to do some aspect of that triangulation, which I would guess, speaking for myself and some of the scientists on the line here, like that's not the most exciting part of it. And I think we could benefit by working together. People can compare their observation to somebody else, start to get some of the points and some of the triangulation. So I wanted to put a pitch out there for, there are many different ways to do triangulation and of course, different software packages. So open source code for that.
Right. And so I've put another thing, Liz, in that there might be funding necessary on one side to do the software development. And then there's the software tools themselves, right? I mean, it's just sort of like both, you know, assuming that everyone's going to do this in their spare time. Well, you know how that works. So that's both a need, a resource need, and a functional need, I guess is the point. Okay. More citizen science needs. You were all in a roll there.
Another thing.
Well, I would think it based out of the what's coming out of the conference. The more we can learn about what it is you need to know, and what data it is, what kind of data you need to learn that, the better we can take pictures. And one of the things I'm hearing is you need better time resolution. And so we need to take shorter exposures and more of them. And even if that means sacrificing some of the aesthetic quality by using a higher ISO or whatever it might be in our cameras in order to get the data, and sacrifice some of the beauty, and the images look a little noisy, but I think Neil Zeller was talking about this a couple of days ago, where you're taking the images for science. Steve is appearing. There's a chance the green pickets are going to appear. And so you switch your camera to a different mode in order to get more time resolution, to see the evolution of the features. But the more we can learn of the kind of information you need and the kind of data you need, sort of spatial and time resolution, the better we can take our pictures and develop perhaps some sort of best practices document or advice that we can put online at places like the resources or area of the Alberta Aurora Chasers and the like, and to say, look, if this is happening, this is the kind of pictures that would be great, this kind of settings to use on your camera, because this would improve the quality of the data that the researchers could use. So we could develop some sort of best practices for getting the best kind of data to research Steve and the other kinds of related phenomena that give you better pictures. And might sacrifice, as I say, sacrifice some of the aesthetic beauty and quality of our case, but it gives better results for you folks.
Related to that, we need to be careful that it's not like the only thing that we can do is, or we want to have is very like 0.5 seconds or 1 second images. That is particularly if we are interested in picket fences. So the question is that we should be able to provide, I don't know, a set of times. It's okay, if we want to get into the picket fences business, we need things for less than, I don't know, 2 seconds. Or do we need everything in less than 2 seconds? I don't think that would be the case, but that would be important. If not, as you're saying, you are going to be losing a lot of things just to be focusing on this very, very dynamic and short scale and short temporal scale of a given feature, but it's only one thing. Then you have Steves, you have star arcs, blobs, a bunch of other things.
To me, I mean, second resolution is not needed for the subaurora evolution. For Steve, for example, because for auroras, it's yeah, you need some kind of a few seconds or so. But for Steve, it's a kind of slowly evolving feature in terms of minutes. Yeah.
I wanted to comment on something Alan said. You know, in regards to me, it almost seems like what's needed is like a Steve webpage, like a central landing pad, like, I don't know, like steve.com or something like that. Something where it would have, because a lot of the images are in different places. There's different, like something that's central where people can go, like a one-stop shop to go look at the database, maybe submit reports, to see like a guide on viewing tips and what's needed by the scientists if you're going to go out and hunt, something like that. And something that we can update, perhaps this family tree of Aurora that came up yesterday, something central, not even more than a central repository, but a central database where people would go to. If that sounds,
you want just an easy to find target with the guidelines that it can be easily updated as things progress. That's
it's a very early 2000s web page type of idea. I don't know if I think is the modern terminology a landing pad where the central point that everybody would go to, and it has all the social media and all that kind of stuff too.
Yeah. And a regular update process too, so it doesn't go stale, because you can spot a mile away when nobody's updated something in a while, because that means, oh, nobody's interested anymore.
GeoCities, yeah, that's right, Matt.
MySpace. Okay, more. These are great.
Just thinking of what Alan said, well spoken, I fully agree, is that the data gathered is as good as the education given to the observers. So what is needed need to be communicated.
Yeah, I can certainly add that while places like the Facebook, Aurora Chase's Facebook page, like, has all kinds of resources, most people never go into it. They don't look at it. They don't find those resources. And we're having to always educate people, what Steve is and how. And so, yes, I would agree. It's someplace that you can just say, go here. And it's easy to remember the webpage. Here's your resources. Here's the information about Steve, and here's how to best photograph it in order to provide research. I think that would be great if we could have something like that where it's just very easy to send people to, and it's not something buried in some science, university science page or whatever that might be hard to find. The URL is simply difficult to find, and so that would be great. Very easy to and easy to navigate once people are there, because these are not scientists, but they want to know, what is it, and when could I see it, and how would I photograph it, and how can I contribute what I've taken.
I also want to emphasize the fact that lots of data exists, but it's distributed into many different web pages. And in that sense, there might be a good idea to kind of select a focused page or focused area, which is always used. I know this is difficult. It's also difficult in corporate world, but using something stable and known like Aurorasaurus for this type of activities might be a good idea, because it's already existing, doesn't need to be relaunched to anyone, and I guess well known enough to be used for this.
One of the things that we were talking among the organizers too, and we wanted to know if this is something useful for you guys as a product of this workshop. And I think the motivation came from Minna Palmroth in Finland. When they were going out to observe the dunes, they created like a booklet to educate the community and to know exactly what they needed to look for. So we were wondering if we could create something like that for the chasers, for the Steve community, and having that maybe in a web page, maybe in a printed format. I don't know. Is that similar to what you, Alan, are thinking, or you guys are thinking? Would that be useful?
Sure, I would think that would be useful, but again, it requires people go someplace and download something or whatever, and then read it all. Just the web page is where most people would get their information, if that information is on a website, I think that would be the most useful place to put it. But a printed downloadable PDF is great to have as well. To
That's
have
probably
it on
the
file
easiest too.
reference. Yeah, certainly. The more ways you can disseminate the information, the better. Or even some videos, but people explaining. People like to watch videos, explaining the process as well.
I want to see your video on that, Alan. It would be awesome. I just want to go back just a second to what Emma suggested, and thank you for that suggestion. And also just point out that we've used the word easy about 500 times the last 5 minutes. If any of this was easy, like I would have done it. We've done so much of this that we've tried really hard and know it's not perfect. But I also kind of want to pivot just a bit to another point, which is related. So certainly a landing site for Steve, for citizen scientists that has educational accessible resources is really important. And also something like commitments to open data and interoperable metadata and things like that. So, platform independent resources can be put together. That's another idea that I think is important because we can link up various systems, and these systems are hard to maintain and continue to evolve. But having commitments to the ways that the data can be shared well by each other, combining a list. I'm not sure if I'm being clear, is what I'm trying to suggest.
Something like that. And I think I'm going to even take all of this out of specific asks, and I'm going to make it its own bullet, because that's really what it is.
Using some central place would also be most cost effective, because maintaining several different sites with same data or partially same data or partially same functionality will be the most expensive way to do it.
Sure.
Yeah, that's a good point. That's a good point. If I could get you some money to do it, I would love to. But that's also, it's really hard to cross countries and things like that with this as well sometimes. So, yeah. Anyway, platforms and reusing existing platforms is definitely something I'm very interested in, and also kind of how we can the sustainability of that across even different citizen science projects. A lot of this actually is similar to what bird watchers need databases for as well. So just some thoughts.
I'm thinking of the proposal of some kind of guideline book, and thinking of the amount of observers in the Alberta Aurora chasers. Or, of course, the development of this kind of material requires funding, but I also see it as a business opportunity for you, even though you are scientists and probably don't look stuff like business opportunities.
Actually, I'm one of the editors for AGU Books, and they have been talking about having books for the public, and this is something that they will be interested in doing.
But yeah, the material Minna and fellows gathered has been very handy, like when interpreting the recent observations of chain of spirals, like just mentioned recently by Chris from Alberta, and the latest observations, stuff like that. When it's cataloged, exists, and the material is available, it's kind of really easy to refer to.
Okay.
And with the folks like Chris Lintott in the UK who pioneered this Galaxy Zoo type of crowdsourcing of data submission, and would they have something to contribute to our needs? And it's very similar. In that case, though, they're giving people data to analyze and then give the results back. This is a little different in that we're getting original data from citizen scientists, but nevertheless, it's a project. It's a project of coordinating and contributing all this data to a central place where people can then analyze it. When might they have something to advise us on as to how to best handle this kind of data acquisition? The various Galaxy Zoo projects, and it's very diverse now, and not just astronomy, but all kinds of areas now.
Yeah, I've looked into that, Alan, and it's a really good idea. Their primary focus is image analysis. So it doesn't, any kind of Aurora image analysis, it is a good idea to consider their free project builder tools, really easier, there I'm using the word, to start that up and maintain that within that family. But I am not aware that they can do all of this kind of thing, although there are other apps and other citizen science projects that are observing, where people are getting out and recording. iNaturalist is one of them.
Right, right.
And if we need to do image analysis in a similar way to Galaxy Zoo, I don't think it would be a plausible or good idea to use people to categorize these images, because there are machine learning algorithms that can do it automatically if there's enough positives of something. And I think whatever it is, we do have enough positives of whatever it is.
Yeah, there's an evolving conversation there about how you can potentially parse different tasks. So some machine learning, I mean, there's just terabytes of data, right? So machine learning can handle some of it, but then there's also some that perhaps human eyes are especially suited for, not going out of business.
That's right, Liz. We call it computer aided discovery here, which is you have the computer do the machine learning do some of the grunt work and then stop and present the issue, present that to the human and say, okay, which paths would you like me to explore more? And so you stop frequently and get the human, insight, but you try to get a lot of the junk work of just scrubbing through a very sparse space done, like over here. It's kind of a blend. People have been talking about that stuff too. Yeah. But machine learning, I think, is a general software tools sort of category that could have potential here. Okay. Anything else you want to add to this particular list?
Maybe acknowledgement to citizen science observations if they're particularly used in a paper or somewhere else. That was.
Oh, you're okay. Right now, let's see, where does that fit? Maybe that's its own. Let's see.
Yeah, Liz had some really good comments about that. I think on day one.
Yes, you did.
And from my personal perspective, I don't think we can be careful enough. I think I'm trying to say, because I mean, in the traditional air quotes academic community, we tend to be extremely careful about who we're citing and giving proper acknowledgement. I'm sure, all the traditional academics on this call can attest to a time where somebody was left off a paper or wasn't acknowledged properly, and the ramifications of that. So I think we need, it's not unusual for us to what I'm trying to say is to put that extra effort in to make sure everybody's getting acknowledged correctly. So I think that's an important point. We need to treat it the same way with citizen scientists in our community, at least.
Mm-hmm. But again, it's a best practice, right? And I'm sure, Liz, for example, or other people, there's been a lot of thought about that, or at least I hope there has been. Hopefully.
Oh yeah, no, this and Alan's suggestion earlier, I could have put that in my talk, but next time.
Mm-hmm. Mm-hmm. Okay. All right, these are all very good things for citizen science needs. I'm just going to scroll back up here. We had the funding question, right, for citizen science participation. We had some suggestions there. We had something about what the repository might look like and what does it need to have, what metadata does it need to have, lots of things there. Bea's first one was a science focus, really, I think, which was, you know, here's a study that might need to, so I'm going to just basically say specific science studies. That's one of them. What other science studies came out of this meeting, folks, that you think I should be adding here?
I can tell you what we haven't talked. I think the picket fence observations, and how do you simulate that? We look at picket fence wise. I think the only talk I heard directly about only this was Josh talk on Wednesday. Am I right? Yeah.
Okay.
And I feel like in this case, the citizen scientist observations are key. We're not going to get the spatial resolution that they obtain in our own instruments, as I said before. So we rely on their observations.
Mm-hmm. Okay.
It seems to me that a lot of what we talked about sort of splits cleanly into two topics. I mean, the point that Steve, everything we've seen so far suggests that Steve is just an extreme SAID, right? So that lets us lean on previous SAID studies, which there are a lot of. And it also lets us split into these two categories of what are the magnetospheric conditions and MI coupling conditions that lead to SAIDs. And then when there's an extreme SAID, what are the small scale processes or mesoscale processes that create structuring and light? And I think those are very different investigations.
Right, and I think along the lines of the, you know, extreme SAID sort of conditions, I would love to have he et al.'s event timestamps and how big each of those SAIDs were, so that if we ever find something new and interesting, we can check, is this just a thing about SEDS that we didn't know before? And that's like, yeah, that's like I said, that's always the question I ask when somebody brings something up is this just a property of extreme SAIDs?
And a very low hanging fruit here is we have looked at the optical data and then look at the satellite data to find those extreme SAIDs. What about the reverse study? Can we look at the satellite data and found those extremely fast flows and go back to the optical data and the citizen scientist data and see if we observe Steve or not?
And to that, I guess luckily we have DMSP to look back on, which may not be as, I think actually probably, and then Swarm, of course, because Swarm's been a workhorse in that too. So
it seems like addressing so many of these things, there are people who aren't in the room that could really help. And so just want to make a pitch that, you know, the meeting could be twice as big at least, and we probably still wouldn't get everybody there, but there's students and there's a lot of people that we really need to make progress on this, and informal educators as well, for, you know, all of this stuff that we've been talking about as well with the citizen science side. So that's low hanging fruit for you.
Yeah, and just be clear that's why we said that we were going to do this first workshop and do more. And so that addresses your comment, really, which was to try to see if we get an initial foot in here, but that this was not complete at all.
So wait for Steve 2.0.
Steve 22, Steve 23. It's the annual Steve conference.
Actually, there are a couple of statistical papers. I don't remember the names, actually. One of them, he guy, Chinese guy, who analyzed, I don't remember, but million maybe DMSP orbits, and has the whole statistics of SAT events. And there was another paper,
2014 paper,
just recent, so it's probably will help to look at the dates at least.
So maybe I have one more point for the specific science studies. What about chemistry under the extreme conditions of very fast sets? Is there a need for more simulations?
Absolutely. I mean, this whole topic here, when SEDS happen to conditions to generate Steve.
That's in there, right? Yeah.
Yeah, there's so much low-hanging fruit there.
So there is a question there.
Evan, yeah.
Yeah, I think Evan has his hand up.
Evan.
Yeah, I guess to the a point a couple of minutes ago about going back and looking at satellite data to try to find Steve events. Similarly, we have continuously operating super darn radars, which have a little bit wider longitudinal coverage. Maybe not the same, precipitation measurements that the DMSP spacecraft can provide, but they are running continuously and at mid-latitudes for over a decade now. So that could be another database to go back through and look specifically for SAIDs or to try to find Steves. Right. And similarly, if there's anything moving forward, if the data don't have fine enough temporal or spatial resolution, that would be good feedback to have for the super darn community, because we can schedule our radars in campaign-based modes to increase those spatial and temporal scales. And particularly as we move forward over the next few years, upgrading the radar hardware, hopefully with imaging capabilities, which Bill Bristow's described. Maybe we can better capture some of the dynamics within the SAID flows.
I mean, those are excellent points, Evan. I mean, and that first point about using SuperDarn to because I have a suspicion that some of these structured flows that, like, for example, the paper, I think Barat showed it, and then I showed a different figure from the same paper, that Oksavik 2006 paper, the first observations of SAIDs and SAPs from, I think it was Wallops, right? And I'm pretty sure he was looking at an SAID. So, doing that line of work is, can we identify Steve signatures in SuperDarn, and then can we use that to go back and do some stats and stuff? It's excellent. It's actually something I've been frustrating my collaborators with for the past 18 months.
Yeah, and just to add on to that, even though they weren't always referred to as SAPs in the papers, there were some radars operated at mid-latitudes in Australia and New Zealand even earlier than the Wallops radar, where they were identifying SAPs-like features in the early 2000s. And, we might not have the same kind of imagery because those radars were looking over the oceans, but, there could be some even earlier events they could possibly compare to satellite data from those earlier Australian studies.
I think the very interesting sort of borderline separate question is, what does a 25 kilometer wide, 4 kilometer per second flow look like to a SuperDarn radar? Because it's very unclear to me.
Yeah, that's something we could try to model, but we can, with some of the newer radars, we can get down to, say, 6 kilometer resolution. There's some trade-offs there, but in the vast majority of the historical database, that's going to be smeared over like a 45 or so kilometer range gate. But if it's embedded within a larger SAPS flow, you might still be able to see the SAPS flow.
Right.
I don't think, I mean, 25 kilometers wide is too extreme. Take it 50 at least.
One comment. I did the calculation for a Steve observed in the very close to the local magnetic zenith for one observer, and I got a width for a Steve in the range of approximately, the calculation is preliminary, approximately in the range of 3-4 kilometers or so. So 25 kilometers could be in some cases an order of magnitude too high for the width of Steve.
No, I mean,
right, but I guess it's the
You're
cross
talking about
section.
SAIDs, not necessarily
Okay.
Steve, right?
Sorry,
Yeah.
Yeah, so and it's also the cross section, like the observations I've seen with Steve and Superdarn, which is one significant event at least, where it's the only thing in town. It's the only thing Superdarn is really seeing at all, right? And I don't know. That doesn't mean the width is 25 kilometers or 50 kilometers. It could be very well 5 kilometers or 10 kilometers. It could just be a ginormous hard target effectively for the radar system, and it'll still pick it up. The one concern is whether you're seeing it broadside with the viewing angle on the radar, or you're seeing it at a kind of a more glazing angle, or more westward or eastward zonal angle.
I'm also going to put magnetic aspect angle front and center here, because that anytime you talk about scattering, that's exactly what you
the aspect condition. Yeah.
Yep. And the problem is that you are mostly seeing edges, not inside, where the gradients are strongest.
So I guess a big bullet point here, Phil, the catch-all would be HF observations and modeling of observations of SAIDs and Steve, perhaps. Is that?
Maybe I'll just go HF observations of Steve. How about that?
Yeah.
And I can go back, I can make that kind of promote that way. There you go.
Now, a question here regarding the connection between SAIDs and Steves is talking about the thickness or the width. Do we expect a one-to-one correlation? Do we expect a wide SAID, but Steve only occurring, let's say, in the central part of the SAID? Or what are your thoughts?
I think the theory is too far behind to answer that.
Okay.
Yeah.
It's a major question. Yeah.
Because we tend to, at least I try to, when I have a structure, an optical structure, and I have a conjunction with the satellite, using or assuming that the data points are connected through magnetic field lines, that helps me to say, okay, which height I'm seeing my optical phenomenon. And when I look at, let's say, the center of my arc being SR arc, Steve, is, let's say, in the location of the maximum electron temperature observed by the satellite, I'm saying, okay, that's an assumed altitude for the optical event. But that doesn't mean that the width of my optical structure should go on the same location of my electron temperature enhancement or the peak of the horizontal velocity be measured at that location. So it could be smaller or a little bit to the left or to the right, not really center.
Yeah, let me maybe make it more complicated.
Yeah, thank you. Thank you.
So, Carlos, usually the heating inside Steve or SAPS is due to heat flux or suprathermal electrons from the plasma sphere, from this region, near the plasma pulse. Ion heat flux is negligible. Ions are mainly heated by the electric field. So ion temperature should maximize near the maximum of the flow, of the westward flow. But with regards to electrons, they are heated mainly due to heat flux and suprathermal particles, collisional heating in the SID region. So there is some kind of feedback. The smaller the density of plasma of ionospheric electrons, the higher their temperature, because they absorb heat flux and heated by electrons. So basically, you should expect higher temperature in the minimum of the near the minimum of trough. And that's one point. Another point that the trough itself is created by the chemistry, by the charge exchange, which is accelerated by high, again, electron temperature and high ion temperature. So basically all points to the minimum of plasma density in the trap.
Okay.
Yep. Okay, we were on a roll there. Any other science studies that were low hanging that you heard?
I have a question of citizen scientist. Maybe this is well known to you guys, not for me. So if you take a picture, that's a color picture. If you split the channels, you have red, green, blue. And Brian made a comment about something I showed in one of the events, that I don't know if this is something that happens all the time, but in my particular example, I could see that, yes, the initial arc observing this event was mainly contribution from red channel, nothing in the green channel, and nothing in the blue channel, without any idea of the characteristics of each channel, right? But what I noticed was that in the green channel, in the region where you were supposed to see the red arc, there was a depleted level of green emission. And right, those were processed then to the original, the CR2 provided the camera, and I saw the same thing. Brian made a comment about the way that the camera takes into account white balance, that could be a fictitious change. But I don't know if you guys have basically taken pictures of Steve or any kind of subaraural structure and then looked at different channels. And what did you see? How can we characterize, are these all broadband results? Are they useful?
I certainly haven't bothered to go into each individual channel when I've had Steve pictures, but that information is there. And if we supply raw files to you folks, then that's available to you to look at and to see what the difference is between the red, green, and blue channels. So yeah, that data is there in all the pictures we take if it can be used. And the best thing is to supply the original raw files to people that haven't been manipulated, and the color balance of those can be kind of set wherever you want as well. So yeah, that's another sort of best practice, is that shoot raw, and if researchers need the data, supply the raw files so you can get extract the most information out of them from the original data that was taken by the camera.
Which wavelengths are actually gathered might depend on the sensor type. So to interpret the data, one probably would need to take a look at the sensor capabilities of recording different wavelengths.
And that would be that would be the specific camera, right, that you're using.
Yeah. Although I don't expect the cameras to have much difference.
Yeah, can I show share my screen and show some slides about the calibration, the color calibration, because we did that.
Okay, kind of briefly, because I'd really like to get back to this summative action.
Quite briefly,
but you you should be able to just share it, and it'll take it away from me, and then I can come back.
Yeah, but I can't share. You can start sharing. So somebody's yeah, okay.
I'm sharing, but I shouldn't. You should have been able to just share without doing that.
Okay.
But there you go. Okay, we can see your desktop.
Yeah, can you see my desktop here?
Yes.
See this kind of this file. Yeah. Yep. So basically, so this is a kind of the photo taken by the citizen scientist.
Move
we
it
are
back.
not seeing it now.
Move it
yeah,
back.
now we just see it your file browser, but we don't see the image itself.
Really?
Yep.
Now we see
Now
it.
we can.
Okay, so let's do it. So basically, so this is a kind of the photo taken by the citizen, the scientist, and so this is what it looks like in the JPEG format. It's a kind of processed format, and I specifically asked for the raw file. So remember, the raw file is very important for this sort of the process. And so yeah, I just ignore that. So the process here, you have the raw file. I got all the white balance information, the color space information, and so I tried to convert it to the standard sRGB and the color white balance. So that is what the color we should see under a normal daylight. That's white. Anyway, in a standardized it. So yeah, so this is the original the shot. They use the kind of Adobe RGB color space, and they're using the SD65 adjusted sRGB color space to convert into this one. So this is the standard. This should be used. This is the standard color we should compare with, for example, our camera system. So yeah, so this is what they captured. And look, this one. This one is the color I built from our spectrograph data. So we captured this event with our spectrographs, and we use our spectrograph data to build this color. And I just let you guys to compare this two. So this can be a kind of very standardized the process. But the important thing is just keep the raw file for us to process.
Right. Okay.
Yeah, that's all.
Thanks.
I agree with you. Okay, so I will go back.
Yeah, take over it.
Yeah, no, thanks very much. That's quite helpful. I'm going to just do this. Okay, let me get back to our notes. Okay, so I think we've got that in RGB and raw files here. And as Emma said, you do have to look at the sensor itself, which is, of course, going to be platform dependent. And hopefully, I don't know what the distribution is between 10 identical cameras of the same model in terms of that spectral response. I hope not too bad, but I don't know. So the effect that has on analyzing it, Carlos, is something that somebody would have to look at, I think.
The one variation is that some of us use cameras that have been filter modified for greater red sensitivity to pick up more of the H alpha, which we like to pick up when we're recording our deep sky objects. And that might make a difference in the, how much it picks up the red. I don't know if it makes a big difference between, for the oxygen reds, but the deeper reds and nitrogen and hydrogen, that will throw the balance off a little bit. Certainly it throws the color balance off on the cameras quite a bit.
Yep, understand.
And so that has to be specified. Or if we're shooting through a filter of some kind, some sort of light pollution filter to darken the sky that might be on the camera by default or whatever, and that needs to be clarified as well, because that changes the spectrum of the night sky if we're shooting through these notch filters, which take out some of the light pollution, as well.
Yep. All just need to be, but I'm going to just repeat what Liz said also. It also does depend on the target that you have for your investigation. There's lots of examples out in the literature of people doing things with relatively uncorrected data, and you can do a certain number of things if you have a good number of observations. And then above that, you need to start nailing a lot of these things down more closely so that you can then do more precise work, and it's a spectrum, right? So Carlos, I think the community could discuss a little bit about what set points are useful for what things, really.
Right. Yep.
Phil, I just want to go back to a point up there under the bullet of conditions that led to when SEDS happen. You had a point about detailed model Gemini. Also in there, we should put global models and assimilative.
Right.
Just so before, in case so we don't forget about those important.
Yep, like AMGO.
Yeah.
Right. Yep. Agree.
Yeah, I mean, sorry to belabor this, but I really think this note is where all of the novel physics is. And I think it would be great to, of course, have this sun to mud model like Naomi was talking about, but I think there's a lot we can do just by putting simplified models as post-processors onto other things.
Yeah, no, I agree with you. So basically, it's like much still to be done with simple models.
Yeah. By the way, this morning I looked at glow a little bit because there's this question, right, of if you put a little bit of kinetics in, you can maybe not have the full kinetic modeling, but a kinetic aspect to a Maxwellian model like Gemini. But glow only has one parameter for it only has one vibrational state basically for O2 and N2. So I think it would.
I don't know if my audio is working.
Yeah, we can hear you.
Okay. I reset my computer. Maybe it's behaving today.
Better.
Good. Yeah, no, I was thinking about this too. The other thing is glow is built to sort of work along a field line. I was kind of thinking if you had, so Brian, if you know the cross sections for excitation, for the different type of collisions we might expect, ion neutral, NO plus, whatever, oxygen, I don't know what's going to be important here, then, you could take the output from a model like Gemini and do some, okay, you have a Maxwellian distribution, there's a high energy tail. You could do some calculation based on that if you knew the cross section. I don't know. I think there might be some like really sort of gross and simple things that could be done to capture some part of the kinetics. And, Phil asked the question yesterday, what stops the energy runaway? And the answer may be inelastic collisions.
Okay.
In the model. I think that might be the answer, Phil, but we should.
Well, so we should just I'm just going to put down inelastic collision implementations. It's just like, are they in there? Right.
No, they're not. They need to be though, because, I'm seeing temperatures of 3 eV.
Okay. So that's a general need. That's a general need then, is that, even doing what's the most bog simple way you can do that, and what does it add?
That's what I'm thinking. I need to follow up with Josh Simon, and I were talking about this last night, and follow up with Brian too, because I think he knows more about the cross sections than I do. But I think we could probably put something together. Hopefully,
it's the thing that Brian said that I really like, that I just highlighted. This is where the real details are that could make a large difference, I think, in just getting a little more handle on it.
Yeah, I totally agree with you, Matt. Some gross thing is useful. You must have some inelastic collisions in there, right? Like you are using the N2 cooling.
Yeah, there's. I need to look at which ones they are.
Okay. Even some of those, like even the simplified Shunkanegi vibrational nitrogen cooling rate, might be all we need. And then we can figure out the rest from there.
Right.
I think I have that, but there was also, this is way off in the weeds, but the old edition of Shunkanegi had like an error in one of those formulas. Right. And I know this because JP St. Mary's told me. So we got to go back and check everything, I think.
All right. Anybody else see the science and technical work that leaped out of this? This is a pretty long list. I'm really impressed actually already. But anybody else see something that was just really obvious that came out of our discussions like yesterday or the day before? I'll just scroll up over here.
Yeah, I have one kind of the experimental the issues. So about ion temperature. So I'm not quite sure about the upper limit of the ion temperature that can be measured with existing facilities. But because for the Steve, from my model calculations, the ion temperature can easily exceed 10,000 K. 10,000. That's quite good. It should be kind of the normal for the extreme side conditions under Steve. But I'm not sure that it can be captured with the existing the instruments. With radar or satellites, is that possible for ion temperature exceeding 10,000?
It depends on the technique. It's really completely technique dependent.
Yeah. Okay.
Sorry, go ahead, Jim.
Mm-hmm. Yeah, if we can kind of actually measure the ion temperature, for example, with radar, but there's a way because the the ion temperature, the enhancement is just proportional, roughly proportional to the square of the velocity. So this is that's kind of the simple rule. Yeah. So if we can actually accurately measure the ion temperature from radar, so this kind can be used as kind of the proxy of the side. So
here's some of the difficulty for things like incoherent scatter radar. You don't measure an ion temperature. You measure an ion temperature to an ion mass ratio.
Yes.
And the real problem, as you know, Jin, is that when you get extreme conditions, the models of what ions you should be using sometimes are not the best, right? And so then you get inherent uncertainties in the temperature, completely aside from how well you're measuring the spectrum. You know, that's a whole nother thing. But so that particular technique has trouble at those extreme temperatures. There's just no two ways around it. And besides, unfortunately, in the volume that you're trying to measure, you also, in those conditions, often trigger plasma instabilities, which completely blind you to the incoherent scatter return, which can tell you the background ion temperature. That's another factor. But you know, if I talk to a ion drift meter or an ion temperature meter on a satellite, there are different kinds of things like spacecraft charging and what have you. So that's why I put it down kind of as just a general bullet. I think that's fine. It's just, one could think about what are the various techniques and limitations, and is there a little window in there?
Yes, yeah, that's important. We know the limitations of
Yep, I agree.
Yeah, thank you.
One of the things.
Sorry.
Go ahead.
Yeah, sorry. I was just gonna say, do we have a DMSP expert? Can we take their raw data and reprocess them with different assumptions?
Evgeny, go ahead.
Yeah, it's DMSP is very, 800 kilometers, 850. So whatever temperature you have in the F region, I mean ion temperature.
Right.
Thermal conductivity is very low, so it doesn't doesn't reach the DMSP. So why you always, when you look at the data, you have extreme electron temperature, DMSP or swarm or whatever other satellite, jump, even jump. But you have ion temperature always below like 2,000, 2,500 K. Right. So that satellite data won't help in a sense, unless you have satellite in the F region.
Right.
And for incoherent scatter, as far as I understood, in STIF you have like densities like below 10 to 4 cubic centimeters, and for any incoherent scatter radar it is so it gives a lot of errors in determination.
It does, and if the density gets low enough, you're inside the Debye sphere as well, and then forget it. It's just going to disappear, and you have no information of the ions at all at that point.
Right.
That information also affects the satellite temperature. When I was talking to the swarm people about elevated electron temperature, they say, "Oh no, the density is very low." But then you realize that it wasn't as low as they thought that it was. So the value of the electron temperature were kind of reliable. But the point of the limitation due to low density also goes to the satellite.
True. And to come out of this rabbit hole, I know we don't want to go too much farther down it, but I know that people have tried to, for example, in less extreme conditions, compare satellite electron temperatures from DMSP to temperatures, for example, from Millstone or other incoherent scatter radars. And there are some offsets that are probably due to things like spacecraft charging too that aren't completely understood. So when you get to these kind of temperatures, you're kind of wandering into very difficult territory.
Basically, there is no very simple estimate for the temperature. I mean, it's in textbooks. You just take reduced system, of reference between neutrals and ions, right? So you get ion temperature as I forgot, 1/3 or 2/3 basically it's a function of this velocity squared, and there is a very simple formula for that.
Right.
Yeah, this is
That's
Unshrunken.
a good proxy for the ion temperature.
Yeah, I want to just chime in though that that's covered in Shrunken Nagy and I think Mike Kelly's book too, but that's a steady state formulation. I mean, maybe it applies at higher altitudes, but it's not clear to me that it does.
You know, it's a matter of a few collisions, so it doesn't actually limit anything.
Right. Okay, I want to get back to this list. Gareth left me a comment that says, whoa, the list is almost as detailed as our notes, which is true. But on the other hand, most of these are actually very rich individual topics. So I don't know that that's not appropriate. I just think that that's how much has been emerging here. We should step back for a moment. Somebody else should look. Have we missed something major here and obvious? Just even in a major topic, and we've got specific science technical studies. We have plans for community expansion. We have repository for citizen scientist data and what that might, qualities of that. We have funding for citizen science participation. We have citizen science needs. Now, the one thing I haven't heard, and Bea, I would call on you, is campaigns, right? We had 2 campaign intervals and we've made some things in here. We have things that we can do with the campaign data that we talked about. We also wanted to talk a little bit about how to trigger future campaigns and whether there were different considerations. So what items do we have from that we want to add to our list of, low-hanging fruit or action items?
So I do think we are missing, as I said at the beginning, looking at the individual events, and the campaigns are excellent for that. Now that there is a little bit more connection and the community is a little bit more cohesive, I feel, keep analyzing maybe one of exactly the same that we did, an event from the scientific data and one event from the citizen scientist data. It's extremely useful. My hope is that in the future, CEDAR, for example, we could propose a session where we could all together look at the data, look at simulations when the simulations are ready, and then go back to individual events. I would also like to hear from more people if they think this is something useful.
Now okay, so then that immediately brings up that some of our community here on the line, of course, don't normally go to CEDAR. So that's a consideration right there, is do we want to make an effort to have people that are here also appear at CEDAR? I think that might be something that we want to think about.
I was thinking CEDAR as you mentioned yesterday, if we keep this meeting every October, CEDAR is kind of halfway or a couple of months before, so that will help us to prepare for the STEEP workshop.
Right. Yeah, for the citizen folks, CEDAR is in June, usually about the middle of June or the 3rd week of June, somewhere in that range.
What is CEDAR?
I was about to
it's an NSF sponsored program. It is essentially coupling energetics and dynamics of atmospheric regions is the acronym. Okay. And it's a conference that has been going on since 1986 or something like that, every year. And it's become a focal point for people who study chemistry in the upper atmosphere, aeronomy, people who study ionospheric variations. The magnetospheric stuff tends to happen in the GEM conference, which is Geospace Environment Modeling, which is held at a slightly different time. Sometimes they overlap. And so the magnetospheric modeling that we were talking about, for example, that's something that would happen at a GEM meeting. But at CEDAR, we'd be focusing more on the system where Steve is happening, okay, where the emissions are occurring. And we have people talking about neutral air glow, for example, during a CEDAR conference. So again, it's that kind of winds and drifts and neutral atmosphere and air glow and that sort of thing. So CEDAR is a nice target for this kind of approach. In fact, if you were to ask somebody in our community maybe where Steve's investigations happen, that's probably like one of the first answers you'd get is, oh, well, you must be doing at least something at CEDAR. By the way, CEDAR is also usually split up into 2-hour kind of workshop blocks. Occasionally you'll have a 4-hour one where they have some grand challenge and they'll staple two together. And in its original form, it was much closer to the workshop we've been conducting here. Okay, very interactive, all right. There are so many things happening at Cedar that sometimes it drifts a little bit more into presentation after presentation. We don't have to do that, all right. We could remain focused, but it is not like an AGU or a AAS meeting where, 15-minute talk, 15-minute talk, 15-minute talk, and like a couple of questions and no opportunity for interaction. It's not really what we're talking about here. So Cedar is a good target. It is, like Bea said, timing-wise, it also does work. It's kind of sort of midway between now and next fall, where we are hoping to do this again. I think that's what we discussed at the end of yesterday, if we could do that.
Yeah.
But the bullet here is, I guess, Bea, so just continue to drill down on these two events that we have. I think they're definitely not by any means done. So
yeah, definitely. The other thing that we are missing now that I'm remembering is we talked about the white paper for the Helio 2050.
Yes, right. So that is, yeah, that goes in a whole separate bullet here.
Lindsay, you have a question?
Not a question, but I just wanted to comment that I'm myself and some other people are doing like the CEDAR, what's the word, like alignment of white papers for the decadal survey and stuff. And like so far we've had like 14 submissions. None of them are related to Steve. So I just wanted to quickly put out there. I was going to send this in an email, but yeah, if someone wants to like do any like white paper Steve related things, please do that. And that should maybe be on this list.
Okay, Lindsay, can I ask a question that I've never been able to get the answer for? When does the decadal white survey white papers open and when does it close?
Yeah, I haven't gotten an answer for that either.
Nobody knows this. I don't know what it is. It's nobody.
Yeah, I've attended like a few decadal like workshops and stuff, but like my understanding is the call has not officially gone out yet. And so that's why we don't have a beginning date or an end date. But my understanding is that they will be due sometime in March.
Actually close sometime in March, really?
Close, yeah. That's what is anticipated at the moment.
And they haven't made an announcement yet as to when it opens.
I guess it's kind of open now because we're all coordinating, but there's not like an official open, if that makes sense. This is my first time doing a decadal as well. So like I'm kind of loose with some of the terminology, but
yeah, just thing you might want to carry back is there's a bunch of people who don't even know that they're supposed to be starting completely because there's no opening date. That's a real problem.
Fair enough.
Can you say a few words explaining what is it?
Okay, so every 10 years in the US, they do a decadal survey, meaning that they attempt to get community input that what are the key science strategic directions for the next decade? Think of it as the 10-year plan, right? And that is done as a community, and then the results of that are written up, okay? So lots of white papers come in, they open, and they have people who can put in white papers on particular topics. And then there's a committee, like Lindsay was talking about, that collates these, kind of comes up with themes and gets the information a little boiled down. That gets issued as a report. And then, for example, agencies like NASA, NSF, NOAA take that decadal survey when they need guidance as to what to implement. And, it's up to the agencies to decide what they want to do, but they use that as their sort of master plan, if you will, for doing things. And it's a sufficiently burdensome process that you only do it about once every decade. And it happens for astronomy differently for geophysics, but for geophysics, it's coming up. So, as Lindsay said, we're about to enter the phase where input wants to happen. There was also, I put this 2050 study. There was a workshop last spring called Heliophysics 2050. The idea was, please imagine what the community should look like in 30 years. What things in 2050 would you like to move toward? And as a result of that, there were some encouragements to form little groups that would end up putting in white papers into the decadal survey, because that's the next thing you do to say, okay, in the next year, 2 years, 10 years, how could you work toward wherever you want to be in 2050? So those are the two things that are getting referred to here. Thanks, Carlos. It's important.
Could I add just a bit to that?
Yes, please.
So a couple of points. One, it's generally for the US community
Yes,
for
right.
guiding funding. And then secondly, however, these white papers, you know, anyone is free to submit a white paper, and a very high level representative committee will be looking at those. It's not always clear how much, you know, what comes out of it. But I do think if anybody on the citizen scientist side specifically, like, you know, wants to write, or from your point of view, where you would see, you know, incorporation into the community in the future, that would be extremely powerful. So, you know, that's an invitation. It could be independent of what we're talking about here, but I just wanted to add that thought.
That's an excellent point. Thank you, Liz. I agree with that.
That was bubbling in my head as we were talking here.
Yeah.
We've leaned on you guys quite heavily for paper submissions. We tend to be supporting, right? And I think it would be really interesting to start one of our own, for sure.
We love it. I think that would be really fabulous. And like Liz said, it sort of puts people on notice. Hey, you know, this is part of the future, and we need to incorporate it and do what we're doing in this workshop, or try to.
Just to like add on quickly on the intersection of like citizen scientists and white paper, the Space Weather Community group, which is like Drew Turner, Jennifer Garnett, again, and like they are like their team is actually like creating a white paper right now that does support citizen science and stuff like that. It's being headed by, I'm looking at a worksheet right now, Alyssa Riley from NOAA, but like maybe like some citizen science input like onto that would be a little bit better, because right now it's a whole bunch of like not citizen scientists. So that should be something I should try and get other people involved in who are here.
I would like to be tied into that, Lindsay, if you're able to.
Yeah, totally. I'll work on an email about that.
And one thing we should say too is that there doesn't have to be like only one white paper and everybody has to collaborate and write the one white paper. You don't have to do that. You can do it. You can do a white paper from citizen scientists involved with this community. Like Liz said, there is this high level community that's going to fuse things, but I don't think there's a requirement that the community get their self aligned so that only one white paper goes in a particular topic. Far from it.
On that aspect, and asking the opinion and the experience of the more senior people in this workshop, what do you guys think is the more effective way to target this in looking at the wide spectrum of ideas that we have in this list? Will it be better if we all target Steve in one white paper, or if we divide it in, we have the simulation results and that should be one white paper, we have the observations, that should be another white paper? What do you think in your experience might be the best strategy?
Lindsay, you have any thoughts on that? I mean, you know, I know you're just joining the committee, but I mean.
Yeah, I've heard like both kind of that, like, yeah, I've heard both perspectives that like, it's good to have like one paper unifying things, but oh, wait a minute, you can break it into a bunch of things. So yeah, I'm not very helpful on that front, sorry.
Okay, my sense was somewhere in the middle, which was some organization, so that you didn't like submit a white paper on the O+O collision frequency dependence on temperature, or something incredibly, you know, deep. But on the other hand, if they have several white papers that show the broadness of things related to Steve, that is both organized and diverse enough that they'll say, oh, that topic is bubbling to the fore. That's just my feeling about what would make sense.
So probably it would be better that the people, starting from the people that are here now, we try to create something that kind of had overlapping edges and that we communicate to write those, right?
And then you add something like SAPs or SAIDs, and then you're getting a bigger picture, not just Steve, this little thingy that is beautiful. No, because you have dynamics, modeling, MI coupling, storms, etc.
And
So
yeah.
I would
heard.
say, just expanding upon that even bigger picture, my personal opinion is that a white paper with Steve as an example as why we need more truly interdisciplinary collaboration and less siloed funding, because we can't even, there's CDAR and there's GEM and there's no matching funds for talking to computer scientists or informal educators, that sort of thing. To me, it's a higher impact to our field overall kind of idea. And I don't know if y'all like that going towards something like that, but
completely
that is
agree.
something.
I agree with that, Liz. And I think that's an and. I think you should be able to take and write a white paper that does that.
Yeah.
And then you can, for example, separately over here, also do a one that says the subauraural region is really important. And then you show this and that and this. And so you get your message in, I think, a couple of different times from a couple of different perspectives. Yeah.
Don't forget FOSR, basically.
Yes. Can you explain that to people, Evgeny, what you're talking about?
Okay. FOSR, it's Air Force Office of Scientific Research. And it's, I think there is agreement with NSF between FOSR. So that to support more interrelated studies between universities, say, and not necessarily including FRL people, but kind of which might be useful, maybe sometimes tentatively for the purposes, for some purpose. It's not necessarily, but somewhere kind of couple of sentences about usefulness for FRL.
Yeah. Understand.
So it's I think there is a special pool of monies, assigned for this.
Yep.
So, and this is basically interdisciplinary.
Yeah.
So you can.
Very much so.
Yeah. No, at least it's another agency which can be applied for. And usually FOSR, they are not experts. So program officers usually send it to us, to Space Vehicles Directorate. So.
I want to ask, we're talking about writing things here, right? So if I go back up here, these science studies will lead to papers. That's the way things usually go. You try to write it up when you've reached some particular position. Writing for the white papers is an attempt to get this topic and these studies on the table for people, like Evgeny was saying, funding agencies, and for the community to recognize they're important, okay? There's another kind of writing that I was curious that the citizen scientists I would really like to hear about, which is writing in the general media. Things like public articles and what have you, because I think I heard somebody mention at some point that having some of the press, the right kind of press, I guess, really helps with motivation. It helps with keeping, the communities, not only their sort of trust that their information isn't getting appropriated and used without, credit, but also just that there's momentum, that there's a community that this is all a part of. What have you all found most effective in terms of getting good coverage in the general press there, and what to avoid, if you have any thoughts on that?
I know Alan Dyer has he writes quite regularly with Sky News. So he's a common author in that in articles in that publication. I have a few connections lingering within the Canadian media that like at CBC nationally, and then some of the more local ones as well. But the national one is one that I would pursue in this context.
Right.
And so, I mean, that being said, I think the comment about the right kind of connections, the right kind of journalist, I guess, is certainly heated and very familiar with what can go wrong when you have the wrong kind. But yeah, those are definitely angles that I think I'd be interested in helping pursue. Certainly within the Canadian market. I've got a few contacts in the US market that are a little bit older now. I don't know if they've aged out or not, but
I wonder whether it's like cultivating a relationship with
totally,
some
100%.
And then you can revisit every so often, right? You can go back to them and say, we have new things to show you.
Mm-hmm.
I think sounds to me like that's a key thing to do.
100%. It is 100%. And we've seen that a few times. In the story of Steve, there's definitely been a few journalists that have jumped on the story when it recurs, right? And it's probably been like, I think 2 years since the last time there was anything big with Steve. I think the last time there was a big story was your last paper, if I remember correctly, that kind of caught some traction. And we see the same, in some cases, we see the same journalists that follow the story and they've had success in that story in the past and they seem to jump onto it quickly. So I think we could definitely chase those angles down. I know there's one journalist in the New York Times who was quite regular with it. I think there was one with Popular Science as well who was picking up the story quite quickly also.
Yeah, in terms of the general news media, I think even dedicated science writers, they still need a headline. They still need something to report on. What's new? We've discovered something new, or as Chris says, a paper has been published. And so they need something, a hook. There's a new discovery, there's a new connection made, whatever it is, there's something has advanced the science that we perhaps as citizen scientists have contributed to. That's a great angle, but there still has to be a kind of a headline discovery. On the other hand, publications like Sky News and Sky and Telescope that I write for, they would be interested more in perhaps how we can instruct the citizen scientists. Articles about that, backgrounders. Sky and Telescope's mandate with the AAS now is very much to promote the amateur professional collaboration. So if there was an article that we could put together, Chris and I and the chasers here, describing what are the best practices, the sort of thing we're talking about here in the conference. What's the best way that amateurs can contribute to the science? I think they would be interested in that. Certainly Sky and Telescope would. With some case studies of citing some case studies of where we have contributed and how that could be improved and built upon in the future. Sky and Telescope, I think, would be very much interested in an article like that. And so that's a more instructional, tutorial type piece rather than a headline news story.
Yeah. Kelly Beatty, who's still at Sky and Telescope, is a person who would welcome, I think, that kind of prescriptive sort of inclusional kind of how-to, right? Okay. How can people get involved?
Phil, I'm definitely getting the feel for a strategic approach starting to emerge in how you guys approach white papers and studies and media. There's almost, I can see layers of tactics that you start to bring in here to You promote a paper, but also then later point leverage that after the fact too.
At Haystack,
this is something that should definitely be followed up. Yeah.
Yeah. At Haystack, we spend a considerable amount of staff time serving on committees, writing white papers, because that's how the ideas get into the community. That's how the community decides that these are thrusts that they want to support. One other item in this general press that I wanted to throw out that I think a couple of us were talking about in one of the telecons we prepared for here is that if I get a random media contact from somebody, or that says Steve or what have you, I would really like to sort of be able to draw on, for example, some of the people in this workshop to add to that kind of article. So it would be nice to have a list of people who would be willing to do that, even within our community, that we could just develop amongst ourselves. I find that those articles are really effective when you can say, talk to citizen scientist X over here. I'm not just sitting in my, the carriage house of this thing. This is a broader effort. And then you can talk together about, we just had a workshop on this, it's a frontier kind of topic. So in this community, we probably have the start of that kind of list. And as Liz said, when we have future workshops where we have more participation from students who would be excellent people to, again, point somebody to for that kind of article. Here's a graduate student working on this kind of thing, and has found out something new. That also trains them up to deal with the media and to get the public message out there. So we could start that, I think, if people think that that's useful.
I already have like a pretty big list of people we've worked with. And I'm sure that Emma and Chris also have lists of people, when we get inquiries and there's too many, we pass them on. And even if there's not too many, but, I don't know that it's a lot of work to do, but I'm happy to offer names if you have any of those kinds of things. And I'm sure many other people here do. I just don't know that there's,
I think Liz is not starting from scratch. It may just be pulling on the resources we already have, but just to have something handy that I could very quickly, for example, know who to
You can
call.
consult your resource ambassador network. We have a whole network of folks.
Okay, so there you go. It's just making ourselves aware of all of that would be good.
The other side of this discussion, is there something that you do not want us to write about? Because a part of this research is always confidential in a sense that you might not want someone else to pick up your research topic, and that might be something to consider and communicate to us.
I don't know.
It's generally best to wait until a paper is published.
That's right. Yeah. I mean,
that's possible.
And there's
only
coordination ahead of time for that. But just as a general.
Yep.
Yeah, of course. But there's the thing that knowing that there's a paper coming out, because I feel that I have I've been blogging about stuff for years, occasionally, and I have one article ready for about SAR arcs, and I might add something to the end about what has been discussed here without knowing if someone is working on an article about that, and I don't want to destroy anybody's work, but it might happen accidentally if I don't know that there's a paper out.
Excellent question.
Yeah, right. So that's keeping ourselves informed of what we're doing and of the proper, that one you don't want to talk about yet because it hasn't been through the peer review process, for example, or something like that. If it's coming out in a paper or if it's in the middle of the peer review process.
I became aware of this problem when working with the Dunes people, since we knew that there would be an article, and I'm married to a science journalist, so it was an effort to keep silent one whole year, and then kind of after a year send the paper to him that by email, and seeing him sitting in the other side of the living room, staring at my email and looking at it
What the heck is this?
That's really funny.
Yeah, still,
Hopefully it didn't cause any
you remember
problems.
there was a workshop on SAPs at the Millstone Hill.
2002. Yep.
And what the success was a paper by, John and Bill. So EOS.
That's right.
That's a good
That's right.
good venue actually to.
So so for EOS is the American Geophysical Union's journal. I mean, it used to be an actual broadsheet that was sent out, that people would read, and it's got. I mean, Bea, wasn't the whole.
Still is. So you still can get a printed version of it, but not every article gets printed. Some of them are only the electronic version. But yes, we can definitely write an EOS. And
Yeah,
EOS
I mean, you've already done that with the young career thing, right? Yeah. So it's how to do it. My point is, yes, right. And those can be more. They don't have to fit into the tiny box of a referee, like the referee.
It's pretty general. It's plain language for general public. So.
Yep. We to add to that, we can also add announcements in community mailing lists, like the Cedar mailing list, JAM, etc. Occasionally you can point out that some result has come out or something like that.
Oh, at least simple information about this workshop, about
sure. Yeah, workshop report, which we're on the hook to produce, but we would like to then take that and use it for these purposes as well, to get the word out to the community.
I wonder if for paper information, I heard Gareth saying we could have a Steve landing paper. Having the list of papers on this topic might be a useful tool for the scientists.
Oh my God, yes.
Yeah, in the landing page where you could say recent publications or something with a link. Yeah.
There was a time when I could keep track of all of them, but that is long ago.
Nope. Not even close. All right. Well, those are all great ideas. I just didn't want to. That's something that if you're stressed for time, it's often easy to say, okay, that would be great, but I've got to get on with it. This is really important stuff. This is how people figure out there's a community and that it's a topic that people are coming back to. And I found it very useful. And we are going to have to deal with the occasional media person, as you've all done, who calls up, was assigned by their feature editor to write something on this funny thing, is stumbling around trying to figure out what's going on, and you have to kind of hold their hand and lead them to something that doesn't look like some of the articles that you see in the Onion.
Actually, I think one of the points to stress is that the Steve, not Steve, but at least for this streaks, green streaks, kind of region, it gives some possibility to, to monitor or to I don't know how to say, to image E-region, which is basically a dark area for any, no rockets in the E-region. Radars are just give you irregularities, right? Nothing else. I mean, super dark. Incoherent scatter doesn't work there. So basically, there is no possibility to investigate the E-region dynamics, And Steve, I mean, visualizes.
Well, what I would say is that you can only monitor the E-region in very limited spots due to just physical geometry, and that we don't have the world tiled with radars every 100 kilometers. If we did, it would be a different story, but we don't. So unlike the F region, which is much, much easier to observe because it's just you got to be close to it. Otherwise, you're going to miss it. And I agree with you. This is if this is another way to remotely sense an area, but that's what something that you could throw into something like EOS, for example, or something equivalent to that basically says new methods to observe, key regions that we've been worried about. Yeah. Okay, Gareth and Carlos and other people. This is a lot. I don't know that I remember anything myself that we've major topics that we've missed. Bea, anybody?
I think this covers
It looks pretty good.
most of
Okay.
what we talked. Yeah.
Yeah. Well, this is direct fuel for the report that we're going to write on this too. And because reports always have to end with conclusions, right? And you want to hit these topics in the conclusions, kind of like the general themes. And this was great.
So, yeah, so one of the things is a question to citizen scientists. Did help you having this kind of interactions? Are you even more lost, or you have more questions? Because that was a kind of a challenging thing just to organize or to think how we are going to be intermingling and talking about things that we are seeing the same thing, but we are using terms that we might not be understanding all the time. So I don't know, after these 2 days, it's something like say, wow, that's too much. We need a second one right away.
Personally, I find it to be very helpful. I've learned a long time ago when I don't need to pay attention and when I probably shouldn't pay attention. Because if it's way over my head, then I'm like, I don't need to know that part. I know that very smart people are dealing with that part. And if I'm like, what I find really valuable is sitting through this stuff, even sitting through the stuff that's going way over my head, is just absorbing some of the terms and the way the language flows, right? I don't need to know I don't need to know what is being discussed specifically, but I can understand at a very general level what's going on. And that just facilitates the conversation, right? Like I can blank out a little bit when you guys are getting really deep into something, and then I'll dig back in when it gets to the point where I'm like, okay, this, like an alarm bell starts to ring. And I'm like, okay, this is a part where I need to listen. This is a part where I can actually make a contribution and I can be part of the conversation, and then I'll tune back in. So no, I find this really valuable, immensely valuable, especially when we're starting to talk about things like white papers, right? Like that's where questions are going to definitely come up, because we'll want to know, what are the tactics necessary to write a paper properly in a way that it'll get the most impact. What topics, right? I'm going to come up. I'm sure I'm going to come up with some topic ideas, and some of the responses are going to be like, that's not really going to help. Or maybe you want to think about this a little bit, right? So those are where I see future conversations happening here.
Yeah, I think it's helped me. It's helped us learn the language to some extent. We may not be able to speak the language, but we can get familiar with the terms a bit more and know what the issues are that you're looking at as researchers. And I think out of this is I'm certainly gathering information about how I can better shoot pictures to help you, because this is what you still need to know, and this would be more helpful, and then we can pass that along to our community as well. And so I think getting the amateurs and the pros together is a great thing. So it's been very helpful, I believe, and I think we'll get some great productivity out of this and improvements of what we can contribute to your community out of this, by all means.
Okay,
Alan, I really like your language metaphor. I can understand German. I cannot speak it at all to save my life. I can make out what someone is saying in German, but I can't speak. It's a great example.
Sure. To that effect, we should also, Bea and other people, remember that we ought to talk at least once in between now and, for example, summer with a CEDAR workshop. We should put a couple of telecons together just to touch base, right? To find out what we're doing and to check on some of these connections that are happening. So that is something that I think we would commit to do if we're going to continue to have workshops like this. We need to keep momentum going. Emma, I don't know if you had any comments on the citizen science thing that was just being discussed and whether you found things useful.
I think that the level of there's a kind of bridge that we need to walk through to be able to write white papers, and the bridge isn't that high. But also personally, we need to make a kind of limit our time and effort that what we are best at. Right. And at some point, we amateurs need to admit that we are best at something else than writing papers. Of course, there are success stories in amateur side, like in the Finnish Halo Observers Network, where lots of new Halo forms have been found, and white papers written about those ones. But still, it requires so much effort that I think personally, I feel like my input in this field is facilitating the local community and probably helping to get access to like observation data you might need. But writing white papers in any fashion, not a chance.
Sure.
Time-wise.
Okay.
It's interesting that you say that, because I kind of think that there's at least something there about like what we do is facilitate that conversation, right? And I think that's where my brain is going at the moment in terms of writing something up, is about facilitating those communications, right? I think that's pretty huge, and how we've been involved in this format as well. I think there's a lot there that we can write on. It might not be a typical type of paper, but I think that would be expected coming from us anyways. We're not going to bring what is expected. We're going to be bringing a different flavor to the table.
I would also like to work with you on trying to come up with a summary of this workshop that is tailored to use with the chasers, with other people. I think that right alongside the somewhat dry report that we have to give to people like NSF who funded us, I think we should target that right away. And that's a collaborative writing process, right? Where honestly, you're going to be leading and telling us what would make the most impact in the community in showing that this is an ongoing thing. But I'd really be interested in working with you on that. I'd learn a lot from doing that.
Likewise, agreed.
Great. Okay. It's like 5 minutes to the break. We're timing this well. Do we have any last comments, or do we want to just sort of break a little bit early and then come back for the last block?
Just a point on the question or the issue of website and all that, and serving the general media. Any kind of central repository like that should have a media section for journalists, where they can go get backgrounder papers, backgrounder information, images that are cleared for use, that sort of thing. Where, as you said, the reporter who's assigned a story and knows nothing about this can at least go to and get a little research. But they've got 2 hours to put a story together, whatever it is these days. But someplace where they can get a backgrounder information, perhaps, that they can look up and research about Steve and the whole just Aurora in general, as well.
That would be very handy. I've taken to directing them to the Chasing Steve documentary. That's sort of been my go-to when they're coming in and they don't know anything about it. Watch this. This is like easily digestible. It's 10 minutes of your time.
Yeah.
Okay. All right. I guess we could take a break now, I believe, right?
Sorry, I was muted and I was talking.
Oh, I'm sorry. Didn't hear you.
Bharat put a good question in our internal Slack channel. And it's about whether or not we are going to ask people if they feel okay sharing the slides. Because if we want to keep information across everyone participating, we should have like a common repository of talks that we can go back.
Right. And we need to make sure that's okay with people. We need to define the ground rules for what the material that's in there, that kind of thing.
These talks could probably go into the website itself, stevearora.github.io thing, if people are comfortable, or if at least a majority of the people are comfortable.
Any feedback on that?
So if someone doesn't want, it's okay. I mean, it's not like we
Absolutely,
are pushing it.
100%.
Also,
100%.
don't
Right.
be shy.
And you don't even have to say it now. You can just say, hey, look, I'd rather keep that back later. I mean, we don't have to do it in the group setting either.
Yeah, I should restrain.
I figured, unfortunately, Evgeny, given some of your constraints, that might have to happen.
Can you share privately? I mean, I need to spend a few hours with your slides, I think, Evgeny.
I don't know, Evgeny, I'd leave that up to you.
No, I would limit. I have to get some get through some internal process to get it open.
What about your book? When is it going to get published? Is it already published?
It's in a month or so. It's just proofreading and all stuff.
Which
Very
publisher?
nice.
Which publisher is it, Evgeny?
It's all severe.
Okay.
The organizers of the workshop will really appreciate a cup of copies.
I don't believe you asked that. Okay.
No,
No
I mean,
pressure.
Electronic copies probably would be available.
That's great. Perfect. Yeah.
Okay, Bea, any other things we want to bring up?
Nope.
Okay.
Take a break.
Yeah, take a break. And then just a reminder is the very last thing is we're going to start with the what the heck was that? So if you've got stuff that you just want to show in that vein, we'll do that. And then we'll try to close this up, I think, and make some plans for the next time we'll talk.
Sounds good.
Sounds good.
Great.
All right. See you in about an hour at 6 p.m. Eastern.
Can I, I'm just going to share quickly an observation. Let's see if I can find it. Give me a second here.
Sure. I also want to tell you that I got an email from Eric Donovan saying that he would like to present. He's coming in at the end of the session, he said. Probably around, I'm hoping 7:30, but probably around 8. He said 6 p.m. Calgary time.
So this is a Halloween themed Steve sighting from 2018 from Calgary.
Oh my God.
Oh, I remember this. This is fantastic.
I remember
this is great.
It is still the best work I've done.
Wasn't there a video with that?
There was a
Or was
video
there-
somewhere.
Yeah.
Yeah. It's just,
Well,
it's
now I
pretty much
have-
the same thing. So.
Yeah, but with motion.
The picket
Yeah.
fences are too far southward, though.
Touche.
It's just great.
It's fantastic.
Yeah.
It's not
that-
my fault that Gareth is too tall.
Hey, but that's accurate. If we take the Steve is taller at higher altitude, I mean, you guys did a good job. Bill is at 110 kilometers.
Right.
Just making sure I wasn't wearing the same sweater as I was back then. That's always embarrassing. Here's a 10-year-old picture. All right. I'll get that out of the way then.
Can I do a screen share test just to see if I'm working today?
Sure.
All right.
We didn't take a group picture.
Is that working?
Yes.
We should take a group picture momentarily after. Yes.
But
We
Chris
saw
has
the
to show his
Halloween
real
costume.
face without those glasses.
Group picture? Then I have to take my shirts on.
You have to take your shirt. What? What do you say?
I don't want to know. I don't want to know what
Okay.
that was there.
Mute yourself.
Megan, did you see the Halloween costume?
Yeah, I saw their Halloween costume. I remember that. That was hilarious. Just awesome.
Hey, yeah, if so, who wants? We should turn on our cameras briefly so that we can take the at least one of the pictures here. Do one of the other moderators want to do that?
I can do it.
Yeah, we just have to wait for. Oh, there you are, Liz. Great. Matt is still collecting audio, and Benji, what's going on with Benji?
Maybe Chris is not here yet.
But he's got those glasses. That's the first thing anybody's going to see in the photos.
Oh, he's here. Yeah, there you are.
Great. Oh, looks great, John. Oh man, no, this is appropriate. I think this is exactly appropriate. Oh, good. There's Alan. Great.
Definitely on brand.
We don't need to stand up for the photos because I don't have my pants on. So, yeah.
TMI. TMI. We don't want to know.
This is live streamed, by the way.
Wow.
There's no
filter.
censor button. Yeah, there's no delay.
Okay, I'll take the
Oh, boy.
picture. Smile. 1, 2, 3.
Oh.
Oh,
my
Chris
camera-
is great. Turn Chris's camera on again.
My camera changed. Wait. It's been going weird. 1 second. There we go. There we
Okay,
go.
perfect.
Yay. 1, 2, 3. Perfect. Got it.
All
Great.
right.
Thanks,
Right.
everyone.
So we were. Wait, Neil, was that you putting up that interesting thing a moment ago?
Yeah, I've got a few interesting things today. So yeah.
Great.
I just wanted to test that it was working because I couldn't get it to work last time.
Okay. So how do we want to sequence this here?
I would say people raising their hands, so we could go, if not a lot of interaction and losing time trying to get. So I don't know if that you think that's a good idea.
Sure. It's okay with me.
Okay. Your real hand, good.
I don't know if I know how to do that. Oh, reactions, right?
Yeah, that's right.
There you are. Okay. We have a
Perfect. Go ahead, Neil. I think you're the first one with a hand up. So
Sweet. All right. So we had a big show in 2017. I was in Southern Alberta for it. And it appeared, is this showing up? You see that one?
Yes.
Yes. Okay. So it appeared like Steve was being blown off. So this was like a KP 7-8 night that everybody in Southern Alberta, all the way down into the States, saw. It was an incredible end of May show that we had. And this was pre-show. This was just after sunset. And while we were sort of waiting for the stats to come up and shooting night sky, this showed up. And the motion is quite incredible. I have the video of it as well. So I will go and try and find that one. 1 minute. One sec. Yeah, it was crazy. So
Does anybody see the date just for fun? Or
is this showing up? No.
Not yet.
Okay.
Not yet. It's still the still photo.
Okay, 1 sec then. Opening.
I don't see a date on that, Liz. Is that what you were looking for?
Sorry, I'll give you a date. 1 sec.
Oh.
I'll tell you the date in 1 second. Sure. Oh, that's not it. Sorry, guys. I'm gonna open the video up first. Does that pop up?
You're sharing only the application with the photos, I think.
The thing you need to do is stop sharing and then start sharing again and put the movie.
Okay, hold on a second then. 1 sec, I'll do that. Sorry, I'm a bit of a Luddite with it.
no, it's all good, Neil. I've just figured out how to maximize your view on the screen. Oh, now it's gone, but it's going to come back. I want to see all your picture.
Now share it again, and now just share the movie or the window where you have the movie.
Right.
Yeah, it dropped off again on me. Hang on 1 sec.
Okay.
That's not it either. Sorry, guys.
That's all right. That's okay. It's this.
We just started. We have time.
Yeah. Take your time.
Same one.
Still the movie. Yep, still. Can you just share your desktop?
This should get it to it. Hold on 1 sec.
Oh yeah.
Why isn't the video coming? Christ's sake. Sorry. I'm trying to bring
There was like a little play button on there.
There was a little play button?
Yeah, in the lower left of that window. Just saw it.
Oh, well, maybe that's it. That's cool.
Yeah, well, okay, let's go here for a second then. This was Thunder Lake in Alberta in 2017 as well, I believe. Started out as a green arc of some sort, and this is looking southwest from my location in northern Alberta. And as you see, it crosses the Milky Way too. And it turned into, second to find the, so it turned into, so there's more of it on the left side there. And then it turned into that later on in the night, straight up looking into the sky. So I think the interesting part of this one is this green blob that started out with a bit of the kind of the red arc that sort of sits above it there as well. So it was an interesting night that a few hours later, it turned into this impressive, very, very flowing Steve arc above us. So
that one?
Yeah, that one there. So this turned into this later on in the night.
Wow.
Yeah.
Did it go from being more to the south to overhead, or it's hard to tell from those two perspectives?
This is a very wide angle lens. So on the top left, you'd see is almost straight up already. So it went from being southwest and almost due west to the end to the south. The streak you see is the International Space Station that went by that day too. And then it was probably 3 or 4 hours later that night that the Steve structure was straight up in the air. So it was kind of an interesting. So, yeah.
It seems that green arc doesn't seem to be uniform, like two big patches of enhanced brightness.
Yeah, here's another one that you can see it carrying on to overhead as well, right?
Like yeah, there's a little faint green thing there. Yep, right.
It's in there as well. Plus, again, you can see the red arc above it as well. So,
but I think Carlos is right, kind of blobby. It's not just a uniform green chunk. It's got variations in it. Yeah.
Yeah. Okay, one more thing right now.
How long is the exposure of these images?
This one was the individual image was, I'm going to say 30 seconds. So it was It was actually shot to try and get the space station, and in just happenstance, it was it ended up being having this structure in it as well. We knew Aurora was coming out that night, so it worked out. Another one, there's the Aurora being blown off its axis there, right? So I know obviously no explanation of it. You can see in the top there is a bit of a green wash there as well, almost like a picket fence that would have been beside the structure. So this is looking west to southwest from my location as well in southern Alberta. And the date on that one, file info, the date on that one, May 27th, 2017. I know, right? So you can see a bit of motion between them. If I go between, you can see how much motion has changed over time.
May 27th, 2017.
It was a ridiculous show. Like it's a banner night in all of our annals of history. So
oh well, geez. Yeah, May 27th. Was it the 27th, or was it the like UT 28th?
28th, I'm sure. Yeah.
Yeah, it would be early. Yeah, DST went to minus 125 at 8 UT on the 28th.
Yeah. That
That's a whopper.
was a whopper. That was a whopper. So anyway, this was prior to the show, before anybody else was showing anything off, that we knew what was going to. We saw our stats coming, but the impact didn't happen for probably another hour and a half. From this when the big show started. So it's very I've got a whole sequence of it with the video, so it can be shared with anybody who wants to see that one. It's a curiosity.
That looks
gonna stop share real quick again and then reshare again my I can do this right. Am I showing up as a video screen now?
Yeah. Well, you haven't started play, but there's
YouTube. Yeah.
Is it running?
There you go. We can see it.
Okay.
Blobabra.
Are you playing the audio here, Neil? You have to have the
audio is definitely fun on this one.
Okay. Zoom doesn't necessarily. Zoom doesn't necessarily share the audio though, unless you check a box. But I like it.
And that's it.
I like it. Oh man.
So this is to prove that there is sound in the Aurora or displays or things happening there.
Exactly. One more time.
Good.
This is via YouTube, by the way. This is my YouTube link.
Okay.
I think there might be a very faint SAR arc in the background.
Correct. Yeah. No, I agree completely.
Neil, that was actually something like an hour or something, wasn't it?
Yeah, definitely. Well, it was, the typical Steve length of the hour, right? When they do come in and come and go. It was during the Alberta Star Party. Actually, Alan, you were probably a few campsites over from me that night.
Might have been there. Yeah. Okay. Yeah, that's
I
the
don't
typical
remember
blob auroras that we see. Yeah. And
is it just my thumbnails right now?
No, that's full screen.
Okay, that's full screen. So this was an interesting one. This is my last one. This was at 61 degrees north, north of Whitehorse, right on the barge of Lake LaBarge, in 2019 in September. And this Steve was seen. This is the first time I had seen it from that far north. It was seen that night in Alberta as well. But the interesting part of this one, if I can get it to advance, is that the Aurora band arc crossed the Steve band.
Oh.
So it was there earlier in the night. You can see where the Aurora band stops, and then later on it crosses over the Steve. So again, I've got a big sequence on this one to share with anybody who wants to kind of explore that one too.
And I assume up is north?
Straight up, yeah. Oh yeah, of course, yeah. Up is
yeah.
Top is north, and straight up directly to the.
Martin Collins had the camera observation of that event as well, and I think Martin is still working on that.
Has seen this one.
Yeah, on this event, it's a kind of a very strange. You can see that it totally immersed in a kind of diffused the auroras. It totally that's quite unusual.
Yeah. Okay, just one more attempt here. I'm going to try and get the video to start. Give me 1 second to see if it's not in this section. The same night, by the way, this scene happened with the Steve too, and you see how it split up and kind of broke away from itself. That's part of that same evening.
Yeah, I see a play in the lower left-hand corner of that one. There's a little play button down there if you want to.
Oh, okay. Sorry. Yeah, my bad. Here you go. Yeah, there you go.
Huh.
Right?
Ooh.
Play again.
Yeah.
I know. Lots of more questions than answers in that one, right?
Jeez. It's all kind of all over the place. Yeah.
Yeah, right?
Wow.
Like even the picket fence is so far broken away from it, and then the green up in the straight arch part of it and split up. And yeah, this was a crazy experience for sure.
What date was that one?
Give me 1 sec. This is the same night, by the way, earlier though, and this is looking straight east. September 5th, 2019.
That's 2019.
Yeah. So same night. So these are within the same sequence, and the changes in it are quite dramatic.
Yeah, there's a little intensification, but it was definitely in the category of mild. DST didn't really get below about -40, and it had been -20 for quite a long time.
I'm just trying to find, I've got one of these might come up as a video. No, anyway, that's it for me. So I'll, if anybody wants to see any more of those things, I am very happy to share those with you guys too. So yeah.
Awesome.
One thing that strikes me is how thin the Steve is, just like Mike Hinencool measured. And so my question is, when you get these coincidences where you're looking straight up at it, does it always look that thin, or is there sometimes where it looks thicker?
I've only ever seen it straight up looking thinner than past ones where we're looking at them from the side. We get them splitting even with the arc of the Steve, and the picket fences getting quite wide, starting at a point at the horizon, kind of working their way into more of a V shape. In any of those situations where they go straight above, I've only really noticed it in a pretty narrow stream.
If I could add on to that for just a second, I was also thinking when looking straight up at it that you really get the parallax of the two different altitudes, the main part of the Steve and the picket fence being quite lower. I think that is easier to see, or perhaps exaggerated if you're slightly off of looking straight up or not. Michael, I wonder if you might have any thoughts on that from having looked at so many of these, but it occurs to me that there might be some ideal geometry, and I'm not sure it's straight up and I'm not sure it's to the side, but like what we're often not in the ideal geometry to figure the two out, but we might actually at some point, like if we defined what that ideal perspective would be, then you could go drive around till you were under it, perhaps. Just perfectly, I mean.
So for the one case I measured, the Steve was not directly in the zenith, it was in the magnetic zenith. So you have to look along the magnetic field lines to get a view showing Steve with sinister north-south extension, and not directly in the geographic zenith.
Well, I've often wondered in the images that we often see, like Neil's from the Yukon or whatever, images of Steve from more northern latitudes, the separation between the main auroral arc and Steve seems to be much smaller.
My experience too.
Steve appears quite close to the aurora, and I mean, I've seen a couple of instances from up in Yellowknife where I've seen an isolated arc just ahead, just a little south of the main aurora, but not way to the south where we're used to seeing it here. And it seems to me that as you come further south in latitude, and as the aurora obviously increases in strength as well to bring it south, the separation seems to increase between
they don't
main
go
aurora
hand by
and
hand.
the Steve.
They don't go hand by hand, no.
Okay.
They're separate structures for sure.
Because in general, go ahead, Liz.
It could just be like the oval is contracted when it's quite a bit farther north, whereas when you see it in Calgary or below, you're having a more active time. So you have kind of a larger auroral oval was my thought. But, you know, we don't have, it could be tested with global imaging. But yeah, Carlos, what were you gonna say too?
Yeah, no, that is, now I'm thinking similar thing happens when you're looking at star arcs, that sometimes you see both the aurora coming south and the arc coming south, or sometimes the aurora comes south, stays there, but somehow the star continues moving and goes really far, but the aurora didn't come out. So maybe, I know it physically means something that you go to lower latitudes, the separation between the edge of the southern edge of the aurora with whatever subaurora structure can increase, something that doesn't seem to be the case when you are farther north.
So just to go back for 1 second to what Michael said, I think that is actually, to me, what you said was when you're looking straight up at Steve, the mauve part and the picket fence are going to be separated along magnetic field lines, we think. So they're not, there's still some tilt. And, but I want to, I think looking straight up removes some of the variability. So it might actually be a more ideal geometry because there's so many different angles. So that was what I was thinking from what you were saying. I'm not sure if it's what you were suggesting or not, but
is this
removing some of the angles is helpful.
Yes, correct.
Is my screen up right now?
Yes.
Yes, so that this is showing like top of the screen would be almost straight up on this, and just having that green and assuming that's, you know, picket fence being parallel to the or in line with the Steve arc in this situation. I'm not sure. Like it's I'd not experienced this green intensity with the Steve arc from southern latitudes.
Actually, also important is magnetic local time. You know, the plasma pulse has a teardrop shape. So that near midnight, it's kind of the distances, radial distances, smaller significantly than say at dusk side. So when time progresses, and Earth rotates, so local time changes, you are at different positions to the plasma pulse.
Yeah.
And that's significant because the plasma sheet boundary is, so the auroral boundary is at the plasma pulse, near the plasma pulse. So I think it's clear, no?
You're certainly right about the plasma sphere's kind of orientation. If you're all the way out and looking back at it, yeah, it bulges toward dusk.
So, and also during, when they say, I don't know, the difference between individual substorms and storms. So that for individual substorm, you have a very clear change of phases, you know, growth phase, expansion, and then recovery, during which Steve usually appears. And so that basically when you, during recovery, that's right, the plasma pulse expands so that the plasma sheet or auroral boundary separates more clearly from the subaurora. And Steve related to set, which stays at the place of its formation. So this time you see the splitting, the wider gap between aurora and Steve. During storms, you can get another substorm, so that the things starts, you know, mixing up. So you can get a new set, you can get new Steve, but this gap, it's not so determined, you know. So the magnetic activity is very important to look at, to understand that behavior.
So, Bill, you have a question, comment?
I was just once the conversation got to a reasonable place, I was just going to show different pretty pictures.
I have that one video teed up now that I think I can share with you guys of the aurora being blown off course as my layman.
Hey, yeah, could you?
I'll show
That
you that
would fit nicely because we saw the still.
And you'll see some green at the earlier part of this video. I'll replay it. There's some green actually in the end here. You can see some green above, probably on the line that the Steve would have been on. And this is looked from the southwest corner of Alberta looking, or southeast corner of Alberta looking southwest.
You're looking southwest?
Yeah. Like looking west, south, west, southwest. North is to my right here. So yeah.
Yeah, Leo is in the center there and setting in the west.
Yeah.
Give the date of this one.
27th of May, UTC 27th of May 2017.
If I remember correctly, this was
Yeah.
the one that there were a lot of views from southern BC and
Wyoming.
Yeah.
Yeah, Wyoming saw this Steve arc or whatever it is at the same time.
Cool.
Yeah, so it's coming straight up and then going straight across like a forest fire would, right? The smoke from a forest fire kind of thing. Yeah. Okay, that's it for me. Thanks, everyone.
Oh, thank you.
Thank you, Neil.
Yeah.
Fantastic.
I wanted to ask real quick, if it's okay, about the observation with the diffuse aurora overlapping, Steve. And I just wanted to ask, that doesn't make sense, right? I mean, is it a perspective effect? Like that should short out the SED channel, right?
That was 61 degrees north. I've never seen it from, 50 degrees.
Okay.
We should check if it's a perspective effect.
Okay, so that's a kind of separate study conducted by some other people. So, but from my knowledge, so yeah, So basically, the aurora during daytime intervals is still on average at a higher latitude than the Steve, but temporarily there's a kind of a brief push out of the aurora towards towards south, and during that brief period, the Steve appeared to be immersed into the diffuse aurora, but that's only lasts for a very brief period. It's not kind of.
Excuse me. There is no surprise that sometimes aurora can,
Yeah, there's a brief excursion of the aurora towards suddenly locally and briefly. Yeah, push towards expand towards south.
So technically, you say the subaurora region disappear.
Yeah, I don't know what happens physically, but we can see what we can know for sure from the data. I can see here because they have the Martin Collins said we have the camera for that event. What we do see that the aurora expand southward briefly and to a very low latitude and then retreat back.
May I share a screen to show you some example?
No, I don't have that. That's the data at hand, but that's from my kind of the personal communication.
I can show the video now too. I haven't shown that video yet, have I? Of that one crossing over?
No.
Okay, let me now that I know how to do this.
Yeah, you showed that to me. You showed that to me. You remember that?
Yeah, of course. I'll give you that right now.
Okay, hold on. It's who's sharing now? This is Evgeny, right?
Yeah, I want to show you this example.
Oh, sure.
How that's the best, I think. It's from Bear paper. Is our so that's what you see. These are streamers. Streamers are, injection of hot plasma jets into magnetosphere from the magnetotape. And 1, 2, 3, 4 after onset here. And you see here DMSP observations in the proper time. So you can see several SID spikes here and precipitation here regarding that. So the point is that the first after onset, this is set, the first, which is created by the onset related streamer, okay? And it stays here. Next streamer comes to the auroral boundary because it's plasma pause moving between the each injections, right? So you can see it intersects basically to come here, it should intersect the previous set. That's the point.
Okay.
It means that auroral region went through the pre-existing or earlier created set. The same can be with Steve. That's it.
Okay. Thank you.
Mm-hmm.
So Nick, you want to play the movie?
Yeah, I'll play that movie now.
Yeah, Brian, you have a comment?
I don't want to belabor this too much, but maybe it's a naive question. How can such a strong electric field be maintained if there's precipitation creating conductance?
That's a good question. I don't understand either. Yeah.
There's some chance that what's being shown in the video could be visible kind of proton aurora. Is that possible? Anybody want to know more about that?
Neil, if you want
tiny
to,
bit of green.
you can start sharing.
Yeah, I'm looking forward to doing it here. One sec. You see me doing my thing, right?
Yep.
Is it up?
Not quite yet. It's working on it. Okay, we still just see your file browser. We don't see the movie.
What's happening?
You just share your desktop and not a particular window. That might help.
Yes.
One second. Let me bring it back up again here.
I was wondering who was Emma saying hi, and then I see, okay. Little Gareth.
Hello, little Gareth. Small helpers.
Bennett's enjoying the pictures and the videos.
Of course.
Future space physicist.
Why is it? Oh my God, I don't know why it's not. Anyway, I suck at this. Carry on with the conversation. I'll bring it up. I'll work on it here in a sec. I can get it. Sorry, guys.
We're here. Who's next?
Bill, do you want to show something?
Sure. So this is going to be here. I will share my desktop. So this is everybody seeing my desktop, I assume?
Yes.
Yeah. I do not need to verify Outlook. Thank you. And so this is an event that I imagine some of you have looked at. I've spent far too much time looking at. It's not particularly weird. Let me step through it quickly, sort of first. These are sort of the
Wait. I think it's important to say whose data is this.
Yeah. This is Robert, or this is Robert Downey's photos of, and I think we talk a lot about, looking straight up the magnetic field line or how crazy it can look sometimes. And I think these photos show one of the advantages of being several hundred kilometers north of the event. So in some ways, sort of simplifying the picture by flattening a lot of the complex structures that we're seeing all on sort of a backdrop. And so, there's a lot going on here, but one thing that the couple of things that I want to point out is just how ridiculous this sort of situation looks, where to me, this looks like there's some sort of source of something here, and like this looks like smoke on a flame is what it looks like. And so is that random? Is that my eyes playing tricks on me? Is that a velocity shear with altitude? Is that the fact that things are going from collisional to less collisional and the drift velocity is going up? What's going on with that? And that seems very interesting to me, where, we see these, like, I think we've seen a lot of these larger scale structures in a lot of the pictures we've seen this week. I think this perspective shows that they are, it shows them linked to the picket fence in a way that is sort of interesting.
Also the luminosity variation that you see between that connection and the picket fence.
From what date is your observation? I'm asking because I have a second example showing exactly the same effect, and yeah.
I am embarrassed that I cannot tell you off the top of my head, but I will have to check.
Okay. I think this is August 30th, 2019. I'm just trying to check the date here. August 31st, 2019 is nearly identical display. I think that's where Robert's one.
I'm sure you're right.
My example is from the same day.
Yeah, there are already a bazillion photos from that date.
From there, you can see that if the picket fence is around 100 kilometers or plus, the arc above it is very close. Doesn't seem to be 200 kilometers, right? Or
well, so this is in fact the data from which I did the altitude profiles that those numbers came from. So the one last thing I want to point out right at the beginning of the event, and then it was I believe it was Megan Gillies that first pointed out that in these sort of early pictures prior to things becoming sort of startlingly bright, you can see structure in sort of the same sort of spatial wavelength as the picket fences that we're going to see in a little bit, but they go all the way up through sort of the altitude range we expect to see Steve. And so it's sort of when things are very diffuse and have not really started yet, there's, I see this, so all of this to me, I mean, suggests tantalizingly a periodic source structure that gets blurred out at high altitudes where you have, less collisions going on or something. But anyway, so I think I think there's a lot of interesting things to be looked at from the optics of events. And this is one
So
example.
this is September 16, 2017.
Oh, there
That
you
one
go.
is?
This one? Wait a minute, this is
Bill,
Yeah.
if you could let me share for a quick sec.
Yeah,
Okay,
absolutely.
so that's September, but we're talking about September 16th. Is that what you're saying?
Yes.
like this
Can you
one's
just
a really good
I'm looking at
example.
your paper.
Stop sharing. There we go.
You have to, yeah.
This one's
So
a really good example of when you guys are talking about that extra sort of red enhancement that you see in the spectrograph data. It's because if there's two layers of things, something like the Regos or the spectrograph, they see everything above them. They're not if it's directly at zenith, they just sort of add them together. So something like that would have the continuum in the middle and then that extra sort of SAR-ish behavior on the top.
Good gracious, look at this. Wow.
So
Same
these
structure
are from August 31st, 2019.
Ah,
A little
yes,
bit-
that's right.
And this is Catalin. So he's fairly north. I think he is usually photographing from around Edmonton, Saddle Hills.
Wow.
But you see the very similar behaviors, right? That wave that seems to be blowing off those green picket fences that are going straight up into the mauve.
Yeah.
And mixed in with the main aurora over the rest of the sky as well.
Well, again, he's photographing from quite far north, I believe.
Is he looking back kind of then? He's sort of north looking backwards at it. So
It looks like he's looking sort of southeast-ish.
that's what I thought. So that maybe the
Yeah.
aurora is kind of to his left and then the
And that would make
the
sense
right.
from his latitude.
Yeah.
I'm just trying to figure out where he's.
Kathleen sent me his time lapse of exactly this event. So
Yeah.
if you like,
Yeah.
I can share the
Saddle
complete
Hills
time
is
lapse.
very north.
So he's north of this is north of Edmonton, so quite far, about halfway to Fort McMurray from Edmonton.
Right. And Robert Downey's pictures were from Mount Robson. It looks like just due south of there.
I think that Megan did publish the paper on that event. Published the paper using our RGB camera.
Here's the video.
Yeah. This is a different evening, right, Neil?
This isn't that same evening. This is the one from just a few days later, really, though. It was 2019 still, but September.
Yeah.
September 6th.
September 6th. Yeah, there you go. And then
Between
the
5 to
pulsing.
6.
I'll go back to the beginning again.
It's definitely moving south there pretty rapidly.
Yeah. Yeah, it's cranking. And lots of rippling, I noticed longitudinally there, right?
Yeah.
Huh.
Okay, officially that's it for me.
Wow.
See, who was it? Brian, I think you were asking about width of Steve a little while earlier. So I like to brag that I have some of the worst photos of Steve. And this one, so this is horrible. So there's lots of urban lighting going on here, washing it out, and it was barely visible. But you can see how really narrow it is. Like there were no green picket fences this night, barely visible to the naked eye, but really, really narrow structure. And that's about all it did.
And
Neil
when you
was
say
with me that night.
very narrow.
Okay.
You're talking about what?
The vertical curtain, I guess I'm going to call it.
Mm-hmm.
The width of the curtain was very narrow.
That's really interesting.
That's the pretty prototypical V shape, though. like when you're looking at it to the horizon, to the east or west horizon that comes, especially looking to the
Yeah.
west horizon, how it comes up from a point at the ground level and then V's out, and that's how we see it, is very narrow and then spreading out. And then when the picket fences do come in, they come in off the right side of that from that latitude.
Anyways.
I just hadn't realized before this meeting the apparent discrepancy between the width of SAIDs and of the Steve emission. If that's true, if that holds up with a closer look at it, that seems important to publish, because up until now it's been Steve is just where the set is. It's just an extreme set, but if it's some special subset of that, that's important.
There's an enormous amount of images showing that.
Okay.
Bill, could I ask you a question about the points that you picked for the height, just to remind me? We were looking at the nice Robert Downey image, and it has the red on the top and then a little bit of different lighter color. But the 200 kilometers, is that pretty much coming from the red? It all depends on where you pick your points, right? I'm just curious if you did any, if you pick the lower mid color kind of region, you get something less than 200 kilometers, probably, right?
Let me pull up, give me a second, and I will come back with the paper. And I think I'll be able to, we can see it.
Yeah.
Now, what
I have it open.
I have a question.
Do you want that I share it?
Yes, please share.
Okay.
Okay.
Do you want this picture?
Actually, go to the next figure, and it's probably the one after there.
This one?
No, keep on. There we go. Because that one right there, right? Because that even shows you. It's just the RGB, but it shows where things are sort of more reddish. But that gives you the actual best guess altitude profile. So
perfect. Thanks for reminding me.
Yeah. But then if you look at it at a different time when those picket fences are linked to the main channel, the separation seems to be much narrower, right?
I'm not sure I understand what you mean by the separation being much narrower.
So right there, you can see these three layers like separated between the green, the whitish, and the purplish. But in the movie that you showed, there were some frames or some moments in which you could see that there was the kind of an arc, and right underneath, you could see an extension, and you had these picket fences. So the altitude separation seemed to be much smaller. I know that's an effect of
right. Yeah, and so what? Yeah, so it's, to me, it seems like actually you could even pick the same one point in time, and where you picked would have a separation or not, because it seems like if you pick, so for instance, what it would look like is like, some of the, 1 in every 5 pickets or something like this would look to have the Steve sort of spewing off of it at an angle. And so if you were at one of those Steves, then it would go directly into, or one of those pickets, it would go directly into Steve. Whereas if you were in between two, then there'd be that gap.
Okay, yes, that's exactly, yes.
Bill, is this kind of what you're describing? In a few seconds here.
Yeah, I mean, that's exactly. It looks like from bottom to top that it's all one structure.
Yeah, that's why you're saying the flame kind of appearance, right?
Well, and especially when you get right to the side, it looks like, they still seem linked, but yeah, the Steve part sort of swishes flowward, if you will.
So
look at that. Huh.
Okay. So the case that Ian showed and I showed, in which at a given point, the arc of the Steve seems to disappear and we only see the picket fence. I think what we are seeing is exactly this without the non-green part. So somehow the only thing that remained from that original Steve in that event on 15 March are the picket fences. The rest of the emission is gone. because here you see the picket fence, and then you see the channel going higher altitudes, sorry. And this was one of the things that caught my attention on the 17 March 2015, that you see the picket fences, but the Steve is gone. But that would be a particular case in which the only emission that remain is the green.
So that's why I was asking earlier about the timing, where the conversation that we had with the Alberta Chasers, because we asked the same question: at what time do you see the picket fence with respect to Steve? And their answer was before, after, during, north, south of it. Yeah. And that blew my mind.
Yeah,
so the answer was basically all the time.
Yes, at the beginning, I think they say the picket fence is the end life of a Steve. You will see at the end, but now we see why you have Steve.
Yeah, I've definitely seen it literally throughout. Sometimes before, sometimes after. Here's another kind of demonstrating what we're talking about. So this was almost entirely picket fence. Well, almost entirely green with a lot of mauve intermixed, but
yeah, I was going to ask the naive question if there's an event where it's just picket fence and none of the mauve ever shows up, ever.
I believe we have come across a few of those. Picket fence only without any mauve.
Yeah, right. No development.
Yeah.
Picket fence comes, picket fence goes. You never see the continuum or the broader thing.
There's an event from, I want to say 2015, I think, where we saw a lot of reports of a picket fence. This was before we were even really talking about Steve. But I don't know what I can say, because all the images were from due south looking toward it. And a faint Steve can be really tough to pick out when you're looking straight on, if it's not very bright. I'll see if I can dig some of those up.
Many of the shows will have a picket fence only component to them, where the red flow or the purple flow disappears or removes itself from the visible spectrum, and it's just the green left, but the purple was always there at the beginning or in the middle or the end. So.
Yeah, Neil, that's what I was curious about, was whether there was a case where the purple just never showed up at all.
Yeah, no, I haven't experienced that myself out of all the shows I've seen.
So, another type of observation that I have not seen is one in which you see a thin green arc that doesn't evolve into pockets or picket fences.
A thin green arc that doesn't.
The arc and then the green.
Oh, I see. But then no development of the green, you're saying.
Right.
There was, so on the Thanksgiving Day evening, there was that period where we had that SAR structure with that green blobby structure below it. I don't know if that's what you're thinking about. Because that never separated into pickets. That was just that blobby structure.
But then you're saying that's not a Steve. You identify not the green blob with the Steve. It's a green blob with the kind of SAR arc. That's
I mean, I was describing. I think of it as a Steve, but
okay.
Or at least having Steve elements. That's the one that we're this one here, where we have this.
Okay, yeah, sorry. I thought I heard that you said SAR, but it's the arc. You mentioned the arc, just the red arc. Okay.
So there's that red arc above, and then it's got those vertical structures, very faint vertical, east to west moving structures in there.
Mm-hmm.
But the green is still kind of blobby and not very sharply formed. It's just
exactly.
Sort of,
yeah, that's what happened that night. And a little bit later, I don't know if Chris had captured it. It became just the red section.
Yeah, I do have that too. Let me see if I can bring that up. I don't know if I can do it quickly here. I'll stop sharing and then.
While you're looking for that, I just wanted to say that recent event where you see that green and it's not the picket fence, it was interesting because it was very clear from the magnitude of different people's photographs of that was absolutely not a camera difference. It was just, instantly, not instantly, but rapidly. You could kind of tell from the citizen scientists multiple perspectives. That was something that just impressed me about that particular one, is I could tell that was different because so many people had picked up on that difference. Whereas back in the early days of the Steve Proton Art kind of thing, it was like, oh, maybe it's just one report and it's a weird angle or something.
Ah, I see.
There
Yeah.
you go. That's from Canada Day, Neil?
This was from Thanksgiving.
All right, Thanksgiving. Sorry.
Yeah, so that was earlier, as the green, as the green faded away, and kind of just the red remained for, and then I've got a time-lapse sequence of this that I'll put together, but this was as intense of just the red, and then it faded away to nothing without any of that green coming back. And you can see northward at the very top right of this image is the red tops of the aurora that were diffused by then.
I see.
And
you were
this was the pre-red, and the top left below the tree you can see just a hint of the red coming on, and this was facing back north again and to straight up. So, and that was what resulted from it 20 minutes later.
You were at Waterton? Yeah.
No, I was in East Kootenays near Cranbrook.
Okay.
So
further south.
Going back to those movies shown by Bill and Chris, if anything, regarding the height, we can say that the picket fence or the green beads stay at low altitudes, and the continuation into the mauve arc is happening at low altitude. It's not like the picket fence can move to a very high altitude as in the diagram that Bill showed. So on those particular conditions, like everything is being compressed down to 100+ kilometers, no move up, right?
I mean, I certainly wouldn't say that, yeah, the picket fence doesn't go particularly high up. Like the green, I should say, doesn't go very high up.
Yes.
I don't know if anybody's done any triangulation on those kinds of green bits there, the blobby, possible SAR related green.
Chris and I are probably far enough apart.
Yeah.
Even with our two images, we could get our clocks together and create something for you guys.
Yeah, it's harder to triangulate on something blobby like that, but yeah, it would be interesting too.
Then there's the notion that since the dunes appear in these blobs from like 2018 case, and the height of the dunes is calculated, then speculation is that the blobs must be at the same height with the dunes, like in this Thanksgiving case as well.
I know some height calculations from Carl Sturmer from the beginning of the 20th century, where he reported on isolated green stationary aurora clouds, which were clearly detached from the aurora, and he did and then published triangulation reports, and they, if I remember correctly, the heights were in the range of 100 to 110 kilometers.
So I was thinking that maybe the Thanksgiving event, if the dunes were also in these blobs, it could also be used as a structure to triangulate on, if the blobs are kind of fuzzy.
Yeah.
Do you want to say anything more about Dune's questions while we're at it? And kind of.
Well, no, not particularly. I have a couple of interesting nights which I might want to show, but let's continue with this topic now, and I can take that later.
Okay. So this goes for the modelers and the people into the small scale structuring. So it seems that the question is, we see these picket fences in green, but also we see that they are related to this mauve arc that doesn't evolve into a limited altitude. You can see like a channel of mauve until it disappears. What are the conditions, or why is it that the only thing remaining is that green part, and you don't have like pockets of green, or why is it not like the Steve in general is separated in pockets?
I wonder if Matt or Brian have any thoughts on that.
Yeah.
I mean, I would guess the green is, it's some kind of instability that's coming up there. So it's much more discretized. And then, something about the chemistry is different at those altitudes, but the higher altitudes.
Yeah, because after seeing these two movies, before I thought, oh, you have picket fence or something independent that occurs at different altitude, related but not directly related to the Steve. But after seeing these movies, they are connected, and somehow the only thing that remains or evolved in its own flavor is green.
Brian, I mean, maybe a simple question is kind of the altitude profile of some of the species you're talking about, right? Is that at a gross level responsible?
It may be. I mean, in general, this seems like an important point if there is really such a connection. Certainly the ion translational vibrational excitation hypothesis probably doesn't work there. The one connection might be the N2A state, which can excite the O singlet S state that makes the green line and also create NO. But I don't know. I'm just seeing this now for the first time, so I need to think about it.
So one question I had thinking about this was from time spent with Jean-Pierre Saint-Maurice, is what the velocity altitude profile would look like based on collision rates, and whether when we start to see mauve might be reaching some critical, for a given electric field, how fast can the particles actually get? It might be that, we're down at 110 kilometers. Well, they can only get to 2 kilometers per second because they're running into things too frequently.
Yeah.
Right.
I mean, that's one of, I think, the advantages of the vibrational excitation hypothesis is that it only works where you can go at E cross B, which is about 130 kilometers.
And so the other thing I've been tempted to do with those pictures is to take a look at collisional, using as simple a model as I could get away with of essentially, collision rates and what that would do for a given electric field and what that would mean for a flow shear, and then see what that means, if that, like, how simple of a picture can explain the angles at which the Steve smoke, if you will, is going up at an angle. Is that just a flow shear that we're seeing?
Exactly. Those are the questions that you guys know the answer to, or how to treat that. Yes. Man,
I mean, this issue with 130 kilometers is just such a weird thing. I mean, 150 is around where the red line gets quenched, and so that makes sense why you don't get red line below there. And in this high heating environment, that's probably even higher. Like Evgeny said, you get this neutral upwelling. But why this all of a sudden this air glare shows up at 130? I don't know.
Well, Brian, did the neutral chemistry get futzed here, because this is definitely disturbed conditions? Is it really going to have to, can you drive it down more? Maybe it's not chemistry though. Maybe it's just
explain maybe a little bit. First of all, the electric field profile, I mean the perpendicular poleward electric field, SID electric field, basically it should be constant up until the closure, up until the region, because there is no potential drop in the tube, or at least it's negligible. All right. Second of all, chemistry, which we are talking about, based on the F region chemistry, a charge exchange, where with O plus dominating plasma. Okay. So because O plus, stays forever, its recombination, dissociative recombination is rate is negligible. And so why the chemistries, when you have this charge exchange with molecules N2 and O2 plays such a fundamental role in the trough formation. And as soon as you are in the region where O plus is not dominating, so it's about, I really don't have it on the top of my head, but well below 150, then this mechanism doesn't work, simply doesn't work. And so, but the trough still should continuing down to E-region heights, because continuity equation, So you have a hole sort of in the F peak, right? F2 peak, and this hole should be maintained, and so the plasma from below comes out, right? While the up above you have upflow continuing, so because it's all in Bob Shank paper 76 or so.
Yeah, right.
And so you have kind of depth. If you introduce depth of the trap, meaning that you have some average background density and the trough minimum. So depth means that you difference between background and the minimum density in the trough. It does not, it's sort of more or less constant. So delta n over n is more or less constant above the F peak, but decreases downward. So the trough kind of is not so distinct in the E region. And the boundary is somewhere, I would say, 140, 150 kilometers altitude. That's kind of general situation.
Yeah, so this 130 kilometer mark is special, if I'm interpreting you right, in that the electric field is only strong above it. And the unique ion chemistry that creates SAIDs is only operative above it.
Yeah.
In terms of the neutral chemistry, I don't know, though.
I'm going to throw up an image real quick just to throw fire on the height issue. Can you guys see that one?
Yes.
Yeah. So just looking at. So is that looking directly below it with the green still below the mauve purple and being right?
I don't have a good perspective meter here. I'm having trouble.
Yeah.
Neil, you were joking with us.
Right? This is
well, that's why I said
Good one, Neil.
Wait a minute.
I'm kidding.
Those are two different pictures. Yeah, those are pictures overlaid from different.
Yeah, no. I wish.
North is to the left, right?
North is to the left, and I'm at 61 degrees north. So north is to the left, and straight up is at the top, obviously.
Oh,
enjoy your sense of humor on Twitter, Neil. I know you're not joking here, but
wow. Okay, that's and then there's some Look at the mauve down at the bottom by the tree,
Yeah.
kind of there. It's striped, really narrow,
But-
3 of them.
So this brings again the original question. See, when does the picket fence occur? Oh, originally we thought at the end. Then we decided it's at the end, in the middle, and the beginning. And now we have picket fences above, below.
I'm like, yeah, we're all at
So-
sea here. Yeah, wow.
I think I've an interesting video related to this effect. This is a video from Mike Gear, also from Canada, and it shows the end of the lifetime of a Steve, which was more or less directly overhead, and it evolves in a very chaotic structure with picket fences in a wide area of the sky, and maybe in such chaotic situations you have the structures at completely different heights. If you like, I can share the video.
Sure.
Yeah.
Yeah.
So this video is on Facebook, and yeah, I played right now. At the beginning there are many clouds, but that will be better.
There it went. Yep.
So this is just the beginning of the development of Steve. Lots of picket fences, and the interesting part is the end of the.
Yeah, exactly.
Right.
Wow.
Oh, whoa.
No. Hold on.
And from that event, there are a lot of images on Facebook, and showing
There
extremely
are like 5
chaotic
or
structures.
6 different types.
Yeah, right. That one. That's number 2.
Yeah.
And then the perspective gets hard.
3.
Oh, there's number 3. Yep.
And that's 4,
4.
5. Yeah.
Jeez.
Yeah. One of those are the ones that I was describing for the 17 March 2015 event, in which you see the arc and the picket fences are seen evolving through the arc with the mob disappearing. And that happens after this, somewhere there. You see? Okay, there's there. And now that gets crazy. I don't know what is that.
Yeah, I don't know what's going on there.
Good luck
Michael,
to
what night was that?
developers.
Sorry?
What night was that, Michael?
Just a minute. I have to look at that. I will check that and write the date in the chat.
Okay.
So I think one other point is it makes me think about all of the substorm debates that our community has had. And so, we are kind of used to having features that are crazy, and then you can't ever get 100% of the substorm sort of features described and agreed upon. So I think that video is really helpful, actually, because it shows that it's the end and that's where it's kind of going crazy, and it provides a little bit of a bigger perspective. But just to sort of make that point about the broader context, what it brought up for me from our field is something like the substorm, many substorm features and debates and things like that. But
so
I also
mean that there. Sorry, quickly. Does this mean that there's more than one potential mechanism or process that generates these structures, or is the same one that it finds different background conditions or different substorm or forcing?
Or the boundaries are moving around and you're stuck, and because that first one went roaring across the sky. It was it was there, and then the second one hung around, right? I mean, it was sitting. So what were all the boundaries doing at that
I think
time?
that might be a question for Matt. You might have some thoughts on that.
I'm gonna play that video that had the still from that the one I just showed while you guys chat.
Yeah.
Sorry, Bill. I thought that your movie was great, but now Michael beat you. Now he's showing that plus a bunch of other things.
No, it's all good. I'm a big fan. I'm a big fan of Michael's.
Ooh.
I have one further interesting thing.
back that up just because that's that section right here.
Yeah, and I just had an unrelated question after we're done.
To me?
Just in general, maybe while we're thinking about this. In so many of these movies, of course, you know, there's little satellites transiting, right? You can see them going.
Mm-hmm.
In your recent data, are you guys starting to see Starlink all over the place?
No, it's not as it's
Good
not,
question. Yeah.
it's not an issue for us.
Not yet. Okay.
No.
Notice I said yet.
The
No,
only
they're-
times I
they're
haven't
only
even
bright.
seen- Go ahead, Alan. Sorry.
Yeah, sorry, they're only bright when they first launch.
Yeah.
Now,
Uh-huh.
with the latest launches for a few days afterwards, and they're an attraction as a string of lights going across the sky. But
Right.
they have darkened them enough that they're down to 6th or 7th magnitude. So technically, our cameras could pick them up, but they haven't infested the sky as much as we had feared with these kinds of pictures.
Okay.
We see lots of satellites, especially in the summertime, May to July, on our northern latitudes where they're lit up all night long, but they haven't been as obvious as we had feared.
I see.
Because they did take measures to darken them.
Yeah,
that video at 61 degrees north in September is being affected by the sun just over the horizon, right? So it's very
Okay.
different. Midwinter here, we see very few satellites because the sun is directly behind the Earth.
Yeah, gotcha.
And
okay.
For my
And
part, Phil, I've had a hard time seeing them, trying to see them.
Okay, so if you really deliberately want to see them, you're okay.
I'm having a tough time.
All right.
But we had a great talk from a researcher at the University of Regina at this Art Star Party in August at Cypress Hills, where she's involved with in the astronomy community with the committee, the organization in the astronomy committee, AAS committee, whatever it is, in terms of lobbying SpaceX and the like. And the calculations show that right where we are, 50-ish degree latitude is the worst, because they all come up to this latitude. They all
Yeah, they're right. Their inclination where they're turning around is right.
So they're all
exactly
coming up,
why I was
all
asking.
coming up here.
Yeah.
And so we should have it the worst here. But of course, at the moment, there's only 1,000 up there.
Well,
and, but at the moment, it hasn't proven to be as big an issue as
yeah.
we had
I mean,
we had feared.
Right. They have changed their phase plan. You know, they had like a phase 1 and a phase 2 and a phase 3. All right. And they have just gotten approval because I think the last phase was supposed to be at 1,200 kilometers altitude, which would have moved slower. They've just gotten approval to do that at 600, so that much more of their fleet is going to be at 600, which for you, of course, means it's going to be transiting faster because that's more LEO orbit. The 1,200 stuff would have hung around a little more. But, you know, they are going to be putting 12,000 up there by the time they're done. So it you know, the numbers are
More than that, I think.
Yeah, I thought it was going to be like
plus Amazon and even.
that's just Starlink. That's just Starlink.
That's just Starlink. Well, yeah, but
there's
but-
OneWeb and there's you know,
and even us in Canada are now planning to launch. Everybody's got to get in on it now. Everybody's got to get them. China, and there's no regulation there.
Okay.
So, but at the moment, it for the kind of things we do, it hasn't proven
Well,
to
that's-
be an issue.
that's heartening for the moment. Yeah, that's good.
Yeah.
Looking back at the movie that Michael shared, looking straight up the fisheye view, so that was Mike Gear. On that same night, Mike Gear was shooting, he would probably have been shooting from Jasper. And that same evening from my latitude, so south and east of him, this was the perspective that I had. There we go. As the greens were showing up, and you can start to see the mauve reaching up from the greens, and then it starts to
Oh,
sort
right
of
there.
flame. And this is
Yep.
changing the perspective. Don't worry about what's going on with the Big Dipper there.
We need a better name than flame, though.
I know. But, Neil, this is kind of what reminding me of your photo, where it's got that.
Yeah,
that
the
sort of-
inline, the
Yeah.
parallel look to it. Yeah.
Yeah. And then this was later. This was much later. 11:52, hour and a half later. And you guys have already seen this.
Yeah.
This perspective that I shared earlier.
It's a long duration Steve event.
I think it was. Well, you know, we saw it in Michael's video. I think there was at least 2 or 3 going on in there.
Yeah.
I had changed locations between those two perspectives because I had enough time. There was so much time in there that we were able to.
But you didn't have
move.
time to fix your focus.
Hey, stop.
Oh, jeez.
This is the very first time I shot with my 50mm. I didn't know what the heck I was doing. I had 2 cameras going this night.
I did this on Thanksgiving night as I bumped my focus out for a big long sequence of that red SAR arc Steve thing. And it's just out and it disturbs me very greatly.
Right here is kind of where I think it's most like what you were looking at, Neil.
Yeah.
There's that weird stuff going on.
And I'm sure, well, if you stop right there, Chris, and if you imagine going north, go back one to there. If you imagine driving yourself north for 1,000 kilometers or more and positioning yourself underneath that, so the green is in line with the purple, and that's what I'm seeing in the Yukon, I believe.
Yeah,
I see.
So this is maybe a question for Evgeny or anybody else. One of the things that was really clear in Mike Gear's video was that although Steve started out being straight, it had these undulations by the end. And does the plasmasphere boundary look like that, or is that some internally driven structure?
Well,
let's see. Basically, there are so-called undulations, but they are larger scale.
Yeah.
I mean, azimutally. So to get small scale, really small scale, like a few kilometers scale, you need active ionosphere. There is no way to create a few kilometers size and longitude or latitude in the plasmasphere. Yeah,
Yes.
satellites do show irregularities, like, ducts kind of stuff, etc.
So
on the plasmasphere during these events. But they are, if you map it into the ionosphere, they are larger scale.
Right.
Yeah,
I would agree with that.
Is it like maybe 100 kilometers? I don't know.
Yeah,
what is the scale? What is the minimum scale that you could get?
Yeah, I think that the 100 kilometer or more is probably the answer to that, right, Evgeny?
No, you can get sometimes few tens of kilometers because it starts with, but then it's hydrodynamic, basically cascading. So you have some smaller scales, but not as small as you see in the streaks or pickets. So feedback and stability should work to make it.
So following up your comment on a different physical process that we observe at lower latitudes, these MSTIDs, these are perturbations in the ionosphere at around 250 kilometers that are related to perturbations in the E region. And the idea is that those perturbations at 250 kilometers, they have a scale size that can be mapped from the E region, and the factor is around 10. So in the E region, you have perturbations of around 10 kilometers, scale size horizontal. And when you go to the F region, those are transforming into 100 kilometers. So
No. I mean, dilution is it's going a straight line. it should be a factor of 10, and that's between the origin and the plasma sphere at L4, 5.
No, this is following up what you were saying, answering Brian's question. If there is anything will be related to the ionosphere, not the plasma sphere. So the question here is perhaps this 10-kilometer or 5-kilometer perturbations that we see on these green structures are related to perturbations 10 times larger in the F region.
No.
Why not?
No. I mean, you have a very clear mapping parameter, okay?
Mm-hmm.
And given the, taking characteristic scale of density perturbation in the plasma sphere observed during SAD events, for example, or SAPS events, and if you map it, you will get tens of kilometers in the ionosphere. And we have, for example, well, maybe there are such events like SAPS wave structures. They appear during fast moving at the front of surge propagating western traveling surge. That's substorm characteristic. And these waves have minimum 15-20 kilometers wavelengths. It's actually strong modulation, like plus minus few kilometers per second. So that's shear flow. And when you map it into the plasma sphere, you get exactly what satellites observe in the conjugate point.
Okay.
So there is no question about it. To obtain kilometer scale or sub-kilometer scale, you need active ionosphere. So feedback should work here.
Wow.
Yep.
Oh, there are. It's not just it's. It has a very long history and has a lot of events explained by that in the in situ observations. So I'm pretty sure.
Yep, you have a number of papers on that.
Yeah.
So we conclude that now we know less, right?
As is usual.
And it's good. I mean,
yeah. It's excellent. Right. That's what we had hoped.
From theoretical point of view, I worked with different active experiments, which are almost in laboratory experiments, etc. Not to mention auroral field. But the more you have, the more confusion you have after putting all the data in one, in one pocket. The better result afterwards, because it makes theoretical and modelers think about how to resolve this seemingly contradictory results or observations.
I see Toshi's here, but he didn't say a word. You should know something. You should, what is your input? You are a smart guy.
Well, I simply agree with your statement. We thought we knew more, but now we understand we know so little.
That would be the main conclusion of it.
I have one more video to underline that.
Oh no!
Already steam is coming out of my head.
Yeah.
Yeah. Oh wow. Ooh.
I have hours of these kinds of videos. Just
you have to wait to show them next time, Neil. After After
Yeah,
everything
we
gets
need
rid-
another one of these sessions so that we
Yeah.
can leave also knowing less at the end of the next one.
Well, next year when everything's figured out, then Neil will show the next video.
That's right. That's right. You need to continue to lead us. Exactly. Right. Yeah.
Still, you need to open
contrib-
that. Sorry.
No, my contribution to science is make all the scientists dumber.
Yeah.
No, we like that.
You are doing a good job. You are doing a great job.
You're doing a great job. This is, yeah.
Still, you need to open the Google Doc because we need to add like 15 more bullet points.
Oh, I know. Well, do we? I don't even know how to begin. Jeez.
So what's next now? Okay.
Well,
So,
okay. So the only things we had left on our original, thoughts here were closing comments. We wanted to see how we could get some feedback from you on the format of the workshop and how you thought it went, and what things you think we should keep, and what things you might want to add, and what things didn't work.
But before that, I think, Emma, there was something that you wanted to show that was not related to the green beads.
Oh, we didn't get that. Oh yeah, please.
Just hastily, this is absolutely nothing compared to what Neil had in his pockets, but still,
okay, never mind.
Let me share my screen.
And while you're doing that, Ian was supposed yesterday told me that he was planning on joining us things, but I sent him an email. I didn't get an answer, so I think we will miss whatever he was doing. Oh, nice! That's a rainbow.
That's something.
Yeah.
Right there.
This is something not by me, but from another very skilled lady from Finland, Satu Juvonen, and she has taken this image, I'd say some probably 70 degrees north, so anything can happen. But I thought this was a bit exceptional because the green belt looks a little bit similar to the Thanksgiving blob aurora. I've talked about that topic enough, and there's 11 nights of blob aurora SAR arc stuff available, but this was something that opened my jaw because it looks like a SAR arc and blob aurora, but then there's this kind of color band turning lila above the whole thing.
Yeah, it's purplish. Yeah. Right.
And this seems to be a separate arc from the rest of the aurora in the north, I'd interpret. However, there's so many stars visible that I have difficult time in kind of seeing the directions in this image. But this was amazing image from Satu.
Alan, maybe you could add
Cygnus and Deneb is at the top right there, the North American Nebula, and so and Delphinus is just below the green arc at right.
Oh, there, yeah.
Cassiopeia is right above the tree.
Yeah.
So we're looking east-ish.
Yeah.
So Alan, would an astro modified camera picked up a different spectrum of light to show that purple on top?
I don't know. No, I don't think so. The astro modified cameras pick up the HA deep in the deep red more, which is more redder than the oxygen reds, but it gets into where the nitrogen reds are. And I've yet to shoot the same aurora with my modified and stock camera to see what the difference is, the very same aurora.
Now we get that purple in regular auroras.
We do. And I'm thinking if this is at 70 degrees latitude, I'm just wondering what time of year that was. That seems like that sunlight hitting the very top of the curtain.
Could be,
and whatever the reaction is that activates the nitrogen and makes that go the nitrogen blues at the very top.
That's
I think Anna is right. I believe we have seen that a number of times. This sort of that shade, this sort of the faint shade.
although the Milky Way is still visible, which makes it a bit later in the night.
Yeah, certainly that's right. It's
think-
not, it's certainly not midsummer or anything, but nevertheless, at 70 degrees latitude, way up there, that's still catching the sunlight, I would think. And I only ever see the blues at the top of curtains in our summertime, May to July or so, is when I see those nitrogen blues at the very, very top of the curtains.
I wanted to give a shout out to Andy Whitteman, who's a University of Alaska undergrad. He's done a lot of playing around with different cameras, filtered, unfiltered. He's really an expert in this, and he's going to be giving his first AGU poster with results that show kind of what you just talked about, Alan, of 2 different cameras and different filters and things like that. So looking forward to that in our MacGyver session in December.
That would be great to hear about. And some people use cameras that are modified where there's no infrared cutoff filter as well at all. The cameras that I have, it still cuts off infrared, but just lets through more of the very deep visible red for the H alpha. But many people have these, what we call fully modified, or where there's no filter, no infrared, to do infrared photography. And so what would those cameras pick up?
Yeah, he's been playing around with those cameras, building them. He's since being since his teenage years as well. So it's excellent.
So then, Alan, I wanted to point out that this event is on September 28th, 2017. That's the event, the night that we had the paper. You took the picture of Steve. At the later time, 5 UT. This is happening, I think it's 2 UT, but I know.
Yeah, and I was a bit confused when I saw this image because it looks like Steve-ish arc, but it's quite directly in the north. But I don't know if that can be interpreted as Steve or not.
Certainly looks like it, but once again, from that kind of latitude, it seems that Steve is always, to me, well to the north, but you don't see it to the south. It's not separated very much from where the main auroral arc would be.
Exactly.
At the more northern latitudes. That's where your Steve lives, is in the north, typically.
Yeah. Then there's one event, one specific night when we observed a very, very short ray-like Steve, both from Finland and from Sweden. And there's a chain of observations related to this same night from different people. And the Steve had a little bit more structure than we'd normally see, nothing compared to what Neil had to show us. But I came to think about these rays with Neil's images and how the kind of ends of Steve bent towards the picket fence.
Right, yeah.
So Brian, I think it sent me a note, which I actually resonate with. I was trying to think of what very brief notes to make from this session, and maybe if you could all help me with a couple of what's the most confusing images we've just seen. That might be useful to just note down. I mean, I think that we've had a couple of things where I don't know how to condense this discussion down. Those of you who are much more used to looking at images than I were, which are the things that stick in your mind from this is, boy, we just turned this on its head.
I've got those images and videos that I shared are in a Dropbox link that I can just sort of send to maybe Bea, and then she can feed them out to you guys if you want to have those.
That would be great. I'm just thinking about if you were to just very qualitatively describe the things that really puzzle people. What would you say?
More internal structure than expected for Steve. Picket fences all over the place.
Right.
Sometimes sometimes above, sometimes below Steve. To me, it's a structuring that is super, super puzzling. And right now I feel like we will never solve it.
Right.
I'd say the connection between the picket fence and the continuum emission that.
Right.
Robert
This
Downey
whole
said.
thing about the flame, which people kept referring to, right?
Yeah.
The smoking picket fence or whatever.
Right.
One thing that we didn't discuss, and I think at some point it will be important, is the altitude limit of Steve. Now, from Bill's paper, if you go 270 up to 300, and basically just like pushing it because basically it's happening. And a couple of papers that I've been involved with or events using citizen scientists, they put Steve at not below 300 kilometers, not above, but in the upper end of any kind of limits from observations and from modeling, Brian, as we talk about this, that you can explain the colors if Steve is down to 130, 50 kilometers. Right?
Can I make your question even more complicated? Since you see the transition between a star arc and Steve, can the structure change altitude?
Oh, thank you. Yes, because
you're welcome.
In the paper that we are working on, when we started, and I show those, I think I mentioned that when we do the mapping from the satellite into the original star arc that is observed by citizen scientists, plus the all-sky camera that we have at Mount John Observatory, we found that the height was 420 kilometers, right? That's a typical height for a star arc. That's a good matching. Then the satellite kept moving towards the north, and in the northern hemisphere, it found the conjugate location. The imager from view was cloudy, so we couldn't do any height determination, but the citizen scientist was taking data, so there was an arc. So we mapped the satellite information from the northern hemisphere at 520 kilometers down to 425 kilometers, assume the same height. And suddenly, all the parameters measured by the satellite, in which you have the increase in electron temperature, the decrease in density, and the peak in plasma flow, were offset. They were not following on top of the structure you see optically. But if you bring the altitude down to 300 kilometers, those points get closer to what you're seeing. So that's what Bea was mentioning. So now we have a Steve that is happening at 300 kilometers that still is high to the nominal altitude that people have reported. So
yeah, okay, I got it.
The other
All
thing
right.
I'd like to see in the literature is the thinness of the arc. I mean, that's
yes, thank you. Yeah, that one just needs to. You're just saying that it's not written. You can't find papers with that at the moment.
Yeah, I mean, it's one of those things that I'm going to leave here knowing, but then it's only a few of us that know about that now. So it'd be great if other people could think about it.
Didn't Bea do that in one of your papers, Bea, where you did the DST one, like quantifying like the width of Steve?
We did that for the statistical study, but that has certain limitations because since we didn't know the altitude, what I did is I took the green line and I mapped it to 110. So I used just nominal altitudes. And I did the same for the red line. So what we need, I have done it, I think. What we need to do is see if we map it to June's or Bill's altitude, analyze what we get again.
Okay.
Got it.
Well, important thing is quenching. I mean, you can get very good rate, excitation rate of the red line, but well below, you have, you know, quenching, just collisional quenching. So it limits the altitude for SAR arc, like for me, it's 300 kilometers and above. It's at least from general point of view, that's more or less suitable. But below, that's no way. Well,
Yep.
I mean, given, for example, data of heating experiments, HF heating, for example, in conjunction with ISCAT or HARP, it doesn't matter. You always have red line. I mean, the mix red and green line, but it's always above, 200, 150, something like that. And below, I mean, red line is quenched very strongly, despite very strong heating.
Yeah, I can't remember. Were there your statistics the red line or the continuum emission?
No, I'm talking about the red line.
Okay.
So we're not necessarily talking about the continuum then. Yeah.
Yeah, but when Mike Hinenkel showed that, that was for the continuum emission primarily.
Right. Right.
No, I mean, concerning SAR arcs.
Right. Okay. Any other just sort of general descriptions?
Another interesting thing I saw was the wavy structure of Steve that Michael showed in his Facebook movie. That may be a little easier to understand than other complex or crazy Steve features, that maybe some sort of cage type of waves. So that's probably something we can test based on what modelers can do. In any case, I'd like to see it, the list of these weird things. Clearly, we need more information to understand these. So we need sky measure spectrograph or some satellite conjunctions. So if we can get that the list of information about location, timing, looking direction, and so on, then we can hopefully get more information. So we can hopefully solve these weird ones one by one.
Yep. Okay. Great. All right. I've captured those. Thanks for the suggestion, Brian. That was great. We'll make sure that appears. Okay. Where are we?
I think Eric just joined us.
Oh. Look. Eric's gotten very young. Oh, here he is.
We were getting ready to say good night, and you just show up. Thank you.
Well, I just came for the after party, right?
Okay.
I see.
This is the part that I'm missing. The drinks afterward.
Yeah. Steve.
Yeah, well, yeah. One of my favorite photos that I have from an AGU, Chris, is you and I standing together with me with 2 beers and.
Right.
Well, Steve started over a few beers at the Kilkenny pub.
So did you guys want to hear from me or not?
Yeah.
Sure. Yeah. I mean, I think you're the last one on the list that I know wanted to say something. Sure. Before we kind of close out.
Okay. It won't take very long, and I only have 300 slides. Don't worry.
I have the cutoff button. Don't worry.
Yeah. I like when Chris started his presentation. He opened it up and he was on slide like 37 of 140 or something, and I was like, "What?"
So, you see, there is an option here that says "put in waiting room."
Yeah, that's right. That's right.
What happened if we click it?
So there we are. Okay.
There you are.
And so this is something that this. I have this project, and most people in our community are starting to sort of know about this project. I'm going to go into full screen mode and then flip display setting. Okay, so you guys see the screen? I'm full screen with Aurora X there.
Yes.
Yeah. Okay. So this is just our I don't want to call it virtual observatory. It's our cyber infrastructure project that we have here at the University of Calgary with help from the University of Alberta. And we got a fairly large amount of money from the Canada Foundation for Innovation, from ESA, from the Alberta government, and we're using some money from the CSA that is matching money it's a matching program. And we've been building out this thing that people can use to identify conjunctions on one hand between satellites and cameras, and we're increasingly starting to put information in, so we actually have metadata now, which is driven off of image classification with machine learning, like Lasse-Clausen's algorithm, and we've, for instance, classified the entire Themis ASI data set with Lasse's algorithm, and it's got its flaws, believe me. And then you can do things like search for times swarm is flying over a Themis ASI while Lasse's algorithm thinks there are arcs in the field of view. And what that does is it vastly reduces the amount of data that you're really searching, and then increases the fraction of that data that's useful. And it's really cool. Very easy to use. And then we have other things, including a virtual observatory and citizen science component. The citizen science component is the part that we're getting the slowest start in. But I wanted to just talk about an idea that I have. So first of all, in our citizen science thing, we have, for instance, the auroral zone, which Bea will know about, and Megan knows about. And it's our kind of answer to Galaxy Zoo. And we haven't really done the legwork to get people using this. But the idea is that we had hoped in the long run, we would like to get involved, working with the Calgary School Board and other school boards around the province, and get kids to classify auroral images as some part of a curriculum. And then we have somebody who's working on our photo gallery, and I'll come back to that. And so I took these from Martin Mail's Facebook page, and I sent him a message asking if I could use these, and he didn't get back. So I guess he said yes. And I just grabbed them because I've just been seeing some of Martin's photos recently, and they really are quite beautiful photographs. And one of the things that I've always been saying not always, I've been saying since I sort of first came across the Alberta Aurora Chasers and now some of the other Aurora groups, is I would summarize it by saying that when Dave Knudsen has started looking at this stuff, and he said, boy, it sucks to be a professional auroral photographer now. I mean, because there's so much fabulous photography out there with the aurora as a subject. And I've been thinking, this has been tried a number of times before, and I would say without great results, right? I think we've had some fabulous, really great connections with people in the Alberta Aurora Chasers and other groups, and then the dunes in Finland unfolded in a very similar way. And it's driven some very interesting science. But the idea of having a gallery that is at once really interesting and engaging to go through, and on the other hand, creates a database of a large number of images that you can say where and when they were taken, right, and by whom, and without, as Alan, I saw Alan had made a comment about this on Facebook, without, and we have we're trying to do this, and we're trying to use techniques that Google and other people use, which are we really don't want to control how people do the metadata, right? We want to let people, if you want to put your images in with no metadata, put your images in with no metadata. If you want to not geotag it, don't geotag it. If you don't want to tell us when it was, don't tell us when it was. But if you'd like to, here's why we would find that useful, right? And then we would have some images with varying levels of metadata, and then people would have in Aurora X, for instance, when people add their own summary data from Finnish Meteorological Institute, they can define their own metadata. So we have a certain core thing that we need, which is very small. And then we enable them to add their own metadata fields. So different programs have different metadata, and that's, I think, one of the reasons why this is going to work, right? And so with the photo gallery, I've been dealing with trying to get something going with Neil Zeller, and the idea is that it's quite onerous, but I'm working on a pathway by which we can get all of Neil's stuff organized in a way to become the core. He's got so much. So it'd be organized to become the core of this photo gallery. And we're engaging with a visualization specialist, a Canada Research Chair in computer science and computer visualization at Simon Fraser University. And she's a former professional artist who's now a computer scientist. And she has, among other things, a BAFTA, like a British Academy Award for one of the pieces she's done. And we're engaging with her, and we're going to employ 2 people for a year. And we're going to try to build, we're starting to sketch it out, but we're going to try to build something that will be really breathtaking and something that people will, I think, want to have their auroral images in, just because it will be really cool. And the idea that we're working from is there's this stuff that's kind of sweeping the world right now, like immersive, beyond Van Gogh or immersive Klimt. And this is becoming a thing, right? You know, and people fill a big, you know, space, real space, with images that are changing and dynamic, and it's an interesting thing. I think it's a bit, you know, people in the art community don't love it really because they think it's very corporate, but people in the public love it. And since we're not trying to get artists to engage in our auroral work, we're trying to get the public. I think this might be a good path to go. And so what I've been doing is Sheila and I, the woman at Simon Fraser, we're talking to the Nickel Art Gallery here on campus, and we're thinking about trying to do something that we would launch a show at the Nickel Art Gallery that was an immersive Aurora show sometime in early 2022. And that we would use images, and we would use people from the Indigenous community for the narrative, and we would do something that was basically a ripoff of Beyond Van Gogh, right? And then on top of that, this would be organized largely at the beginning around Neil's stuff, right? But what I want to do then is because Sheila is a professional artist and she has great connections with Canada Council for the Arts, then the idea would be that we would do successive shows online. They would be available for showing in real space, but successive shows online, and that we would create something that people like Christy Turner or John Anderson or whomever, right, could apply to Canada Council and say, you know what, I want to get a couple months of my time to put something together, and then apply for the, you know, Canada Council. The way it works is you basically apply for your salary, right, you know, and some little costs, right, but their costs are tiny compared to our costs. And you apply it to get, you know, if you know, so if you have a day job and you want to take 2 months off your day job, you argue what I need is 2 months of salary at that rate, right? And so the idea would be to create something that would give people a chance to create something, right, that would then go into this. And because we have unlimited storage space, right, then we would just keep these, and people could then come through in a virtual sense, all of these galleries, and then they'd be available for museums and, you know, people like the Prince of Wales Heritage Center up in Yellowknife and other places. And so this is something I just wanted to toss out there, that you know, my goal is that I want us to have all of the auroral images from the community in our data set, right? And I want them to be accessible and discoverable by scientists and by each other, by you know, so that people in the various auroral communities can really see what everybody's doing. And then it's there. It's not, and this is no criticism, it's not in a Facebook feed, it's not in an Instagram feed. It's in a place that you come in, and that we have a decade probably, because this will be funded for long after our build section is over, which is at the end of 2022, right? And then we'll build something that will keep growing, right? And something that and we've been very careful, you know, with Aurora X, we've been very, very careful to not associate this with the University of Calgary, right? So one of the things that's happened in the past, we have data, you know, we have, you know, data centers crop up, but they tend not to work if they're too tightly associated with one place, because, you know, FMI, rightly so, Finnish Meteorological Institute, doesn't want their data to be seen as part of Eric Donovan's empire, right? It's not good for them, right? You know, they need, someone's going to do a paper with their data. They need people to know it's their data, right? And so when we're doing this, we're being very careful to make sure that we're trying to create something that will naturally attract people in the scientific community and in the creative citizen science community, that that I think would benefit that creative community and benefit the scientific community. And the last thing I'll say is that one thing that before the pandemic, and because of the Steve stuff, Chris Ratzlaff and myself and Dave Knutson here have been having some discussions. One of the things I want to do is hold a workshop and have interested scientists and interested aurora chasers come together and spend 2 or 3 days looking at what the aurora chasers have, right? Just show us what you got, right? And then talk about how we could use this stuff, right? And how we can capitalize on it and capitalize on that massive amount of work from a scientific perspective. And so that's all I had to say. It's more just kind of a teaser, because this is good. This is unfolding slowly, because these things do, and we're being very careful about the way we're doing it. But I wanted to share it because it seemed like an appropriate venue to share it.
Mm-hmm. So I'm proud to be a part of this too, as the initial sort of major contributor to it, the archivers. Just looking at my 2015 and 2016 records in my Aurora archives, I've got 57 days alone of Aurora events.
Yeah.
From those 2 years alone, right? Which equal 74,000 photos. And those are like sequences that can be 900 or 1,000 photos at a time for time lapses, right? So, but it's an ambitious project, and I'm so looking forward to get started at it, because it's just what a way to put a real use to this, that we were all using it. It's just a hobby for us, right? Like every one of us up until basically Steve, to be honest, all of us, this is just a hobby outside of our day, our earnings and day work that we've done, aside from Alan, right? Alan's been, doing this as a job for a long time, the night sky stuff, but it's so incredibly, and even to be a part of this project alone right now, the Steve conference this week, and contributing makes every moment out there with our frozen toes in the middle of the night with things growling at us that we can't see worth it. So thanks to all of you for including me and the rest of us from Alberta here, for sure. We're just really happy to be contributing. So,
and I'd like to follow up on something you said, Neil, which is, you're talking about 74,000 images, right? And one of the things that is good, one of the things that the U of C group has to offer this thing in general is that we have been running cameras since 1972, right? Since 25 years before I came to Calgary, right? And we have, in Themis ASI alone, it's now 1.3 billion images, right? And we have about 500 million images in Rego. We have, and so we have, and so basically your data sets are large on a home computer for a person, right? And they're small for us. And so what we have to do is we have to kind of figure out how to take the tools that we have that make the data set not large in that sense, and then shift our focus into the creative, like how to access, what's the best way to, how do we do this so it doesn't look like Instagram, right? Like how do we do this so that you can kind of go through this and you're kind of cruising through some kind of parameter space, which is characterized by the content of the images, right? And viewing it in 3D and all of this, and we've got ideas, and we're open to any ideas. But one of the things,
Eric,
yeah,
I take 10 pictures from Neil, and I leave 1,000 from Lucky Lake to you, so don't worry.
Absolutely.
Now, related to this, do you have plans to include some of these images for scientific use in the same similar way that you have this in this project? The fields of view of different, the Themis and Rego have a picture of an aurora.
Yeah, so we're working with a visualization company in Calgary called BizWorks, And this is what our, I'm not showing you this online, but this is a visualization of the globe, and you can go in and you can spin it around, and you can cruise around in time. And the idea is, so this is for this particular time, these are the Themis all-sky imagers that were operating in that minute, right? At that minute. And then but the idea is where we're going with this from the scientific point of view, right? Is, let's say that we were wildly successful, and in 10 years we had 100 million or a billion images of the aurora from the community, right? Photographs. And then half of those are tagged time and place, right? Well, then you cruise through day after day, and you see the little flags, the little miniature pictures coming up, and here's what the pictures are now. And then you've got a nice, because again, for me, there's two uses for our data, right? For me, there's two uses for your data. One is direct in the science, right? So Bill Archer notices that, or whoever noticed that these two auroral photographers took pictures of the same Steve from about the right separation, and Bill takes that data, and Bill does a triangulation study and rebuilds the height of Steve, right? Or the Neil Zeller observations at the heart of the Semeter group work at Boston University, right? So that's where the image becomes data, right? Like in a very real sense, right? The other use for it, which is, I would argue, at times more valuable, right, is how, we got 3 covers of geophysical research letters because we could associate a absolutely appealing, Bea would find an image, and I think of one of the guys sitting on the lake, the frozen lake, right? And that's an image of the Steve that we're talking about in this paper, right? And that gets us on the cover of GRL, and that gets us on the cover of the Globe and Mail, right? And that attracts people to our field, right? And it engages people in our field. And so there's on the one hand, the stuff being data, and then on the scientific side of Aurora X, we want to be able to tap into that. And again, Aurora X, all Aurora X is, just to be very clear, like I've had a lot of experience with this virtual observatory stuff, and I've got a lot of hard feelings about kind of the way a lot of that's gone, because what we're really being very careful to not stray very far from our mission. And our mission is to make the data discoverable. Not to do science for people, to make it discoverable. You go off and you do your own plots and everything else, we will find you the event you want, right? And then on the other hand, so there's not the one use. The other use is, of course, I mean, frankly speaking, eye candy, right? It's just really pleasing visual images, that make our stuff look really cool, right? And that, I mean, it's a huge advantage that we have. And like if Steve was a line plot of the cross-track ion velocity, no one would know about Steve, right? Like no one, right? Because Steve is this beautiful thing in the night sky, and that's why, and you guys capture that beauty. That's why people know about Steve.
Yep.
To me, there is also a lot of societal gain out of this. And this is coming from being a South American, probably, that doesn't have the possibilities to see the aurora like Canadians do. So if I think about the immersive experience, that brings a huge value for the people that might never be able to go and see the aurora.
Yeah, well, I think
it to Buenos Aires and Santiago, big hit.
Well, I mean, I think so. I mean, I'm aiming at one thing here, right? Like, I would like to do one show in real life, like not in real life, but in the real world, as I tell my video game addicted son. I'd like to do one show in the real world, And again, we'll build off of Neil's stuff to start with, because I just think it's just a pragmatic thing to do, frankly. But I have this feeling that there's some chance it could catch on. Right? There's some chance it could lead to something like Beyond Van Gogh. Right? I think it's not impossible. And and so we just have to, hope.
Yeah,
I want an Academy Award.
Engage the VR app world too right away, because there's so much in just relaxation VR these days. Yes. I just got a headset for my birthday, a Quest 2, and I sit there and I play these really beautiful little games with my hands and stuff in there now, and I can imagine surfing through these images in virtual reality, especially with the videos and whatnot. Martin Mails might be another guy to engage, because he does those starting already, does 360-degree time lapses of the Northern Lights, and it's where we're going with this is to that virtual world as well, and this to have that kind of opportunity is huge. So yeah.
Liz has her hand up.
And her mic off.
Yes. Hey. Yeah, so I just wanted to offer that you did say that you want to use people in the Indigenous community for the narrative of a very nice sounding art exhibit. And I wanted to say that's not what we should be doing.
I'm not.
Let me just finish, Eric. So, I just wanted you to think more about that. And also I wanted to say about the citizen science that it is not, there's many different ways to do citizen science, and it's related to whether citizen science is extractive or going more towards co-creative and benefiting citizen scientists. And so I think that there's more to think about with respect to that as well, because it's also more powerful and sustainable. And yeah.
So I won't speak to the second piece, but to the first, I will say that the Indigenous piece would be done by an Indigenous group of educators, and I would have nothing to do with it. Just to be clear.
Right.
So I mean, it's going to be an important part of this, and it is going to be done by the right people.
That's good. It's not using people for that, though. Yeah. Different ways to hear that.
Whatever.
So.
I mean, I'm not thinking of myself as a particularly exploitive person, so
Okay, any other comment about what Eric presented, or any other thing?
Okay. Well, I think. What were you going to say, Carlos? I'm sorry.
No, nothing. I thought if you had something to say, or anything, a piece that we need to finish up or something.
I'm just going to remind people that we're going to. The only things left really are, we could make some closing comments, and I would actually let Bay and other people start those. But what I just wanted to say was that we will have another one of these workshops. We've already decided that among the committee. Nominally, maybe we'll do this particular one in another year. This particular format, we'd like to have everybody to Haystack if we can do that at that time, because we couldn't do this in person this time. So we'd like to do that. We talked about having a CEDAR workshop. We talked about, putting this group together again on some cadence for telecons, not 3 days, but a little shorter than that, just to check in on what we're doing. We will be writing up the workshop results in a report. And like I said, we'll be communicating with people to try to see if we can also provide a version of the workshop report that is less formal, and maybe that could be distributed to the other communities that we've had represented here. So we're going to do that. And we think we'd like to collect some feedback from you all on how this went. I don't know that we're going to do that live here, but we'll try to send you some kind of a way that you can send us your thoughts about it, because we'd like to also incorporate that into a future one. And we'll be.
And we are open to negative, in quotes, comments or things that could have done better, or other things that we didn't try.
Let's call it criticism.
Yeah, no, right. Tell us what didn't work for you, and we'll take that in too. Yes, exactly. And we do intend to also, among our little committee here, think about, proposing for another workshop, and so we'll work that out with the funding agent in the U.S. here, Alan Liu and Aronimi from the National Science Foundation, and we'll talk to him, I think, about the results, probably with a copy of the results of the workshop in our hand, and then try to creatively figure out how to keep this going. So, I mean, that's where we're going with it, I think. I hope you agree, like I do, that there was so much that we've unlocked or just opened up in this thing that we definitely need many more of these. I hope you agree. I think all of us in the steering committee do. So that's all I wanted to say for that, except for just to thank everybody profusely. I've learned an enormous amount in the last 3 days, and we were worried before this. We've left all this time in the schedule. Are we going to be able to fill it? We shouldn't have worried. I mean, we're not even close to being worried about that part. And that's not just because we have a few people who, can expand on things. It's just that everybody was this interested. And so I really want to thank everybody for a tremendous amount of energy in participating here. I thought that was really, really excellent.
And particular thanks to the people in Europe, because I think you were the ones that had to endure more than we being here at 5 p.m. or 7 p.m. You guys were rock, and you were all the time. So that's great. Thank you.
Exactly. Bea, I'm going to turn it over to other people. So Bea, go ahead.
Just thank everybody. As Phil said, I think I didn't sleep the night before the workshop, thinking, how are we going to put these communities together? How are we going to enable the discussion? We didn't have to do anything. You guys did all. And I am extremely impressed of the time that you dedicated, especially the citizen scientists, the vertebrate chasers, Emma, Michael Hanukkah. Thank you so much. You guys are absolutely amazing. You're dedicating your time to this and to help us. And this makes our community and our work incredible, more important and rich. It's not only about the science, but it's also about the community and how we can contribute and how we can create a more synergistic type of community. And I love how everything worked on this. On a side note, I have been taking snapshots during the talks. So maybe we will create something like a photo album from the first Steve workshop.
Yep.
Yeah.
And
thanks to the students also.
Thank you. I was going to say that's exactly Valerie and Benji. Thank you so much for hanging in there and really helping to make this flow smoothly too, and participating so directly in all of the stuff that was shown. We really thank you again for that. That's been great.
Thank you guys for having us. It was amazing to be here.
Other comments that either from the other committee members or anybody?
I just put a text in the chat with I was sorry. I'm really sorry I wasn't able to attend most of this, but what I saw was like this looked like a really, really good meeting, and yeah, it's really, and it's also honestly good to see everybody.
Yeah.
Yeah, I concur very well. I was really, how to say, doubted that, but really a lot of information, even new. I had read basically all the papers concerning Steve recently, trying to write down a chapter on subarachnoid arcs. And so I thought that what a kind of new thing I would hear. But that was a lot of new things, to learn about. So thanks a lot, guys.
Great.
I'd add that my work is your work. Like if my art inspires your art, then it's all available to you without reserve. So if you see anything that I've done, you're going to find a bunch of it on Aurora X here, hopefully soon. But if you're working on something and need the visuals and the timing and the locations and whatnot, just ask. I think Chris and John and Alan and everybody involved on our side of it would say the same thing. So we just love being a part of it. Boy, I'll tell you, this is one of the coolest things that I'm involved in, as my name is attached to NASA and MIT and VU and all the places that are doing things. So it's pretty great.
Yeah,
Thanks.
absolutely. I concur with Neil, and it's just wonderful. I can remember being asked a couple of decades ago, is there anything that amateurs astronomers can contribute to Aurora research? And the answer back then was, well, no. I mean, the professionals can do it all and the like. And then along comes Steve, and it just changes it. And plus the whole citizen science movement as well. It just changes it. And it's a marvelous story about how amateur photographers have contributed to, and in this case, even kickstarted a whole area of professional research. It's a wonderful story, and there's media traction there as well, as we know with it. And so we're happy to continue, and it's just tell us what you need, and we'll try to feed you as the right data as best we can, depending on what your needs are.
I wanted to add something, which is, like I've gotten in the habit, and you guys, everybody in the Alberta Aurora Chasers group knows that I do this, but I call it crowdsourcing a figure if I need one. And like I'll go on to Alberta Aurora Chasers and I'll say, I need an image of an arc with the mountains in it and the arc just a little bit above the mountains and hopefully some water too, right? And then by morning, I've got 100 beautiful images to choose from, right? And it's such a great way to fish for images. It's just hilarious.
I really enjoyed the format of this whole week. I think it wasn't even breaking down barriers because it didn't feel like there were any barriers. I think certainly some levels of conversation were above some of our heads, no doubt, but that was okay because it didn't feel like that. It didn't feel like those were insurmountable barriers, and the conversations were very easy to follow. They were very easy to inject into, and it was very, well, again, easy. It's really just, I think everything that I can say about this week is the communication went very smoothly. I really enjoyed it, and I loved the conversations we had.
Great to hear. Thanks.
Okay, any other comments?
Well, I also want to thank the organizers, and this was a very unique meeting to bring citizen scientists and scientists together. And like in today's sessions, the scientists got so confused about, how crazy Steve is. Yeah, so you guys gave us lots of challenges to solve from now on, and that's very important for scientists. So we have so many exciting things to do, and hopefully that can keep driving this meeting. And yeah, I really look forward to the future meetings of this series. Yeah, so Phil and everyone else in the organizing committee, you guys done a great job. This size of meeting was, I think, just right. If the meeting becomes too big, it's harder to have this kind of intense discussions. Yeah, so I really appreciate the format and atmosphere you guys created for this meeting.
If we do this, at one point you said your head was smoking, and
yeah, still smoking now.
I could hear the frustration in your voice, and it was wonderful.
So Bea, do you have a screenshot in the moment that Chris, Neil, Alan, and Emma are smiling, and we are all like, "What is that?" I will give proof of what Toshi is saying.
I look for one for sure. I have one of those.
Yeah,
Then we're like,
still laughing, and Chris like that exactly, and we are like, huh, what? Getting there?
Yeah, I was
I must-
staring at my screen, for every images like what Carlos did. It's just so crazy Steve images that we didn't know.
Yep.
Yeah,
So if
I
we
got
can
to
do
say,
Sorry, if we can do this meeting in Finland, I'll host photography workshops.
Ah, there you go.
I was going to say, Bea sent a text maybe 20 minutes ago that says effectively, "Oh my God, we're never going to figure this out, are we?"
And that's music to everybody here. Trust me.
Okay, well, thanks everyone.
All right, on behalf of everybody who not only put this together, but most importantly, everyone that showed up here. And this takes me back to when I was a graduate student and we had real workshops where everybody showed up in a room and they brought what they had and they laid it down and we tried to figure out what the heck we saw. And I am so thrilled that that's what we managed to accomplish here. And we will definitely work to do the same kind of thing going forward as we scratch the surface of all of this. So thanks, everybody. It was really great. And you'll be hearing from us again.
All right.
Thank you.
Bye, everybody.
bye.